Good afternoon, everyone. Can you please give me a confirmation if the audio and video are clear to you all? I want a confirmation in the chat. Uh, Acha, thank you for the confirmation. In the course of the lecture, any question you have, you can put out your doubts into the chat and I will try to respond as many doubts as possible. So with that, let us begin with the session for today. So this revision session, which is a 7-day revision session. So let us look into let us talk about the topic for today. So today, as you are aware, this is day one, and each of these 7 days, we will be having 3-hour long sessions from 2 to 5 p.m. And in these 3 hours, we'll try to revise whatever is important. Now, what is the idea of this revision session? For instance, if you look into today's topic, what is the subject we are looking into? We're focusing on 3 subjects today. That is climatology, lighting, and acoustics. These are the 3 subjects we're going to revise in today's lecture. So if you are aware, in our classes, for instance, climatology, lighting, acoustics, these together in our full length batch, we cover it in close to 30 plus hours, 30 to 40 hours. That is the time we spend on these subjects. Obviously, in 3 hours, you cannot expect us, or uh, even I cannot teach you 100% of the things. The focus of revision session is to channelize what you know towards the orientation of the examination to score as much as possible. So if you have been preparing, and if you have learned, or if you learned from college, if you learned on your self study, or have learned from the classes, the coaching classes, wherever, whatever source of your study has been, now in the last moment, it is important to revise the concept and orient it towards the examination. And today's session is focused on that. So let us say, for instance, you without a proper revision, if the base idea over here, if you are able to score, say, 60 marks, let us say, uh, the idea of this revision session is to push that at least by 5 to 10 marks and move forward by 65. So you will be in a position to score 65. That is the whole target of our, say, this 7-day revision session. I hope it will be helpful for you all. So in the course of the lecture, try to maintain a proper running notes. I will also share you the questions which we have been discussing for your self-study. You can also cross check and also, by the way, the recording of this session also will be available on your mobile app. So you can also cross check if you missed out some question, or if you're having any confusion in some part of the lecture. You can rewatch the recording of that particular lecture whenever you have time, as per the availability on your mobile app. So that's about the introduction to this session. So without any further delay, let us right away begin with the topic for today. That is climatology, lighting, and acoustics. As per the official syllabus, climatology, majority of the part of it falls into the common part. For example, it is both in common and architecture part, the climatology part. If you look into the last year's paper, however, questions from climatology have been asked only in the architecture part. But in 2022, if I tell you, the weighted climatology was the subject with the highest weightage in the whole question paper. Out of all the 24 subjects, climatology was that subject which had the maximum weightage of 8 marks in the year 2022 question paper. Of these 8 marks, you will be surprised to know 5 marks of questions were asked in the common part itself. Only 3 marks of questions were asked in the architecture part. So you can get a good number of questions, a good weightage of questions from climatology into the common part of the official syllabus, or into the question paper as well. Lighting and acoustics is majorly a subject of architecture part. So that's an introduction with respect to the subjects we are going to deal with today. So the approach for us in this revision session would be, in the topic of climatology. Now, there are a lot of topics, there are a lot of theoretical and also numerical concepts in the topic of, say, climatology. You have climate responsive design, you have passive design techniques, you have concept of natural ventilation, you have concept of thermal quantities, where you have numericals of U value, R value, thermal conductivity. So there are a lot of terms. You get a lot of theoretical questions on the measurement unit, measurement instruments. So there are a lot of various types of questions which are possible. We will try to cover the important areas of it. So in the lecture, from climatology point of view, I will be discussing some important thermal quantities, some basic aspects of solar architecture. That would be the basic focus of the lecture for today. We will also solve some theoretical questions of past gate. So the focus in revision will try to practice questions mainly from past gate question papers, particularly both theoretical and numerical. We'll try to say solve some questions also. I would request you all to switch off your videos. That way it would be less confusing to every one of you. So please stop your video, everyone. You can just have a view of maintain a running note of whatever we are discussing. So let us first revise some important concepts of the climatology. You can also maintain your revision note so that you can revise it before the examination later on. So as far as climatology is considered, the first point, let us look into some important thermal quantities. So questions from thermal quantities can be asked from definitions. They can give you a definition and ask you what is it. They can ask you questions of measurement units in the form of match the following. Also questions have been asked in the past. So let us recall some basic uh, thermal quantities and the definitions and the measurement units, and then we'll move towards the numerical part of solving questions related to U value. So the first one, you can make a note on the heading as thermal quantities. As the name suggests, what are thermal quantities? These are set of parameters or properties which you measure to understand the thermal performance. So we as architects, when you design buildings, you'll need to understand the thermal comfort level of these spaces. You need to understand how much heat will enter into the space. So in order to calculate those aspects, to understand about the heat gain and thermal comfort of spaces, we use these thermal quantities. So let us look into some basic thermal quantities. Point number one is thermal conductivity. In brackets, you can write K. Thermal conductivity is denoted by K. What is thermal conductivity? It is the measure of a material's ability to conduct heat. As simple as that. It is a measure of a material's ability to conduct heat. That's called as thermal conductivity. So you measure thermal conduct. 2 points to be remembered. Number one, thermal conductivity is measured for a material. It is the ability of a material to conduct heat. So if a material is a good conductor of heat, it will have a good thermal conductivity. As far as measurement unit for this is considered, it is measured in units of watt per meter Kelvin or watt per meter degree centigrade. So that's the measurement unit for thermal conductivity. Now the next point, the second point, the reciprocal of it is called as thermal resistivity. Now we will also discuss how to use these terms. Why do we need to measure thermal conductivity and resistivity? You will understand that in a while. We will look into that part as well. So the second thermal quantity is thermal resistivity. It is 1 by K, the reciprocal of thermal conductivity. What does it measure? It is a measure of material's ability to resist heat. Conductivity is measure of a material's ability to conduct heat, whereas resistivity, as the name suggests, it is a measure of a material's ability to resist heat. The measurement unit for thermal resistivity, I'm not going into the details of where are we getting this measurement unit from. So you measure thermal conductivity using Fourier's law of heat conduction. I'm not going into those basics because we are focusing on revision, that too from gate point of view. There are no numerical Fourier's law of heat conduction. So I'm not going into that part. So the measurement unit for thermal resistivity is meter Kelvin. It's the reciprocal of thermal conductivity. So it is meter Kelvin per watt, or it is measured in meter degree centigrade per watt. What is common in thermal conductivity and resistivity? Both are measured for a material. I cannot ask you what is the thermal conductivity of the window, because window is not a material. Window is a building component. I cannot ask you what is the thermal conductivity of this wall, because wall is not a material. It is a building component. You measure thermal conductivity and resistivity for a material, and remember the measurement unit. Those are the first two definitions under the thermal quantity. Now moving on. Other than these two, you have two more thermal quantities which are very important. That is U value and R value, which are also called as thermal transmittance and thermal resistance. Let us now look into those two. Let us make a quick note of those 2 points as well. And then we will be looking into the numerical relation between these terms. So the third point under the thermal quantity is thermal transmittance. In brackets, you can write it's referred to as U value, or this term thermal transmittance. It is also referred to as air-to-air transmittance. In brackets, you can write is referred to as air-to-air. So in the examination, if you come across the term air-to-air transmittance, you should not get confused. It is nothing but U value. What is U value? U value is measure of a building component's ability to transmit heat through it. That's called a thermal transmittance. It is a measure of a building components. So this is not measured for a material, it is for a building component. A measure of a building component's ability to conduct, you can say, or transmit heat through it. Transmit heat through it or across it, across the building components. A measure of a building component's ability to conduct heat through it or transmit heat through it. That's called as thermal transmittance. So this is measured for a wall, not particularly a building component, but not for a material. The measurement unit for this one, this is something very important, has been asked in GATE directly as an MCQ question also once. What is the measurement unit for thermal transmittance? It is measured in watt per meter square Kelvin or watt per meter square degree centigrade. That's the measurement unit for thermal transmittance. So thermal transmittance, if I just give you a basic example, if you know about the thermal conductivity of a building component, that will not give you a full picture of it, how well it will conduct heat. For example, I'm using a material, I'm constructing a wall, let us say, using a very bad, let us say, very good conductor of heat. If I say the material used in this wall is very good conductor of heat. When a material is very good conductor of heat, it will have a high K value, high thermal conductivity. The thermal conductivity point. If I say I have constructed a wall using material of high K value, can you always tell that it will conduct heat in a large quantity? Not necessarily. What if I am constructing a very thick wall with this material? Even though it is a good conductive, a material with good thermal conductivity, if I'm constructing a wall with a huge thickness, it will resist heat. So that aspect is considered in building components. Just by knowing if a material is good conductor or bad conductor, you cannot understand how much heat will pass through the building component, because the heat which passes through a building component does not only depend on the conductivity, it also depends on the thickness. So that's the reason, that's the background why we actually measure U value. Anyways, let me not confuse you. Focus on the definition and the measurement unit for now, and then we'll look into the mathematical relation between them. The third point, the fourth point, the reciprocal of U value. The reciprocal of thermal transmittance is called as thermal resistance. That is R value. So the fourth point and the final one under the basic thermal quantities, we'll study some advanced thermal quantities like solid, temperature moving further. But for the introductory part, these are the four things we'll be discussing. And then we'll look into the relation between these terms. Thermal resistance. Do not get confused. It might sound similar to thermal resistivity, but it is very much different. Thermal resistivity is for a material, whereas thermal resistance, which is also referred to as R value, is the property of a building component's ability. It is a measure of a building component's ability to resist heat. So it is for a building component. It is a measure of a building component's ability to resist heat. I'm trying to make a note of the definitions on the board also, so that I would expect you to maintain a running notes of these points so that you can revise before the examination as well. This is a revision class, but you also need to do your self revision after this session. You will still have, so we are having this 7-day session starting from today on daily basis. So I think the last session will be on 27th. So after that also you'll be having approximately 5 days of time. You need to revise your notes once again before the examination. That way you will recall all the important points for the examination. So that's the idea. I'm writing the basic definitions over here, maintaining your own parallel running notes on this. The measurement unit, it is just the reciprocal of U values. Measurement unit for this will be in meter square degree centigrade per watt, or you can also say meter square Kelvin per watt. That's the measurement unit for thermal resistance. So these are the four basic thermal quantities. Now the question comes, what is the use of it? What are the formula? What are the mathematical questions, relations you need to understand with respect to U value? Let us learn those points now. So I hope these 4 pointers are clear. First two, that is conductivity and resistivity, are measured for material, whereas U value and R value are measured for building component. Now let us move on to the next point, that is with respect to the calculation of U value. How do you actually calculate U value? So with respect to U value, there are three important concepts, U value and R value. With respect to these four definitions we saw, there are three important numerical concepts which you have to remember. The first and foremost is based on the definition of U value. which is basically the use. Why do you measure U value for building components? It is used to measure the rate of conductive heat gain through a building component. So uh, the conductive, or you can say rate of heat gain, or to be exactly specific, we measure the rate of conductive heat gain here. Rate of conductive heat. What is the meaning of conductive heat gain? Conduction is the type of heat transfer. The heat transfer is of three types: conduction, convection, and radiation. Using this, you basically measure the conductive heat gain, how much heat gain happens through a building component. Just a second. How much heat gain happens to a building component to conduction. So rate of heat gain, rate of conductive heat gain to a building component. So there are direct questions asking you how much is the rate of heat gain through this building component. How do you calculate that? Rate of conductive heat gain through a building component. It is denoted by Q. That will be given by U value of that building component multiplied by area of that building component multiplied by the delta T, difference of temperature across the building component. So what each of these terms here are, you can make a quick note on what these terms are. U value, you know, this is U value of the building component. Whichever building component you want to measure the heat gain through, that is the U value of that building component. This A is the area of that building component, the surface area of exposure. And delta T here is the temperature difference. Temperature difference of what? Temperature difference across the building component, inside minus outside, or outside minus. That difference of temperature is called as delta T. So that is the first basic formula, which is very important. I have 2 mark questions directly on this formula. Q is equal to U into A into delta T. So if you know the U value, multiply it with area and temperature difference, you'll get the heat gain value directly across that building component. The second basic formula which you need to remember, the mathematical relation you have to remember for U values with respect to the U value, that is thermal transmittance, U value of a multi-layered wall. So it's like U value of a wall section, or U value of a wall section, you can say. Not necessarily only wall. You can also use it for slab, you can also use it for window, any building component. I'm just mentioning it as wall, but it is for any building component. U value of the section of a building component. There's a formula. You can, in other words, you can say U value of a multi-layered wall. What is a multi-layered wall or multi-layered building component? Any building component is not necessarily made out of a single material. It can have multiple layers. If you take the example, for example, of a wall can have a cavity in it. A wall can have plastering over it. You can have a brick wall with a plastering on both the sides. You can have a cavity within it. You can have a double layered brick wall with a cavity. You can have double layered brick wall with insulation filled in between, or you can have a wall with insulation cladding on the outside. There can be different combinations of a wall. There can be multiple layers in a wall. So when you're having a multi-layered wall or multi-layered building component, how do you measure the U value of it? So it's like this: a wall section, let us say you have a brick section, brick cross section, then you are having a cavity in between. Let us say you're again having a brick layer. Not necessarily only brick, it could be any material. For slab, it can be an RTC slab, then with a insulation layer below it, or insulation layer, or let us say tile cladding on top of it. There can be such a multiple layers in a slab also. Let us say there's plastering over it. So there are multiple layers in this wall section. This is a cross section through a wall. So here, if you want to find out the U value of such a wall section, you'll need to know the thickness of each and every layer and the thermal conductivity of the material used in each and every layer. Each and every layer will be made out of some material. The thermal conductivity, what is thermal conductivity again? It was the first point we discussed, that is K. K value of each and every layer should be known. So let me mark over here. Let us say the thickness of the first layer is L1 and the thermal conductivity of the material used in the first layer is K1. Right? Similarly, let us say the thickness of the second layer is L2, whatever material it is, and the thermal conductivity of that layer or of the material used in that layer, that is K2. Similarly, the thickness of the third layer, let us say, is L3, and the thermal conductivity of the material used in the third layer is K3. Similarly, let us say the thickness of the fourth layer is L4, and the material used will have a thermal conductivity it might not end at 4. That can be 5, 6, 7, so on, even till 10 or 20 or 30 also. There can be multiple layers. For every layer, you should know the thickness and thermal conductivity. Then you can use the what if the second layer is cavity space? Ajita, whatever it is, even in case of cavity, even this is a cavity, you will need to know the thickness of it and the thermal conductivity of it, right? uh, Thermal conductivity of the air gap, basically whatever material, or even if it is a hollow space, you can have the L value and K value of each and every layer of the wall, right? So now, how do you calculate the U value? There are multiple formulae within this, or multiple ways you can write that formula within it. So basically, U value is not additive. So you cannot add the U values. Like, I cannot say U value of this wall section will be U value of the first layer plus U value of the second layer. U value is not additive. Why is it so? Because U value is measure of the ease of heat transfer, how easily heat is transmitting through a wall section. If you're adding layers, if I'm making the wall thicker and thicker by adding layers, the ease of heat transfer will not increase, right? But the resistance will increase. Basically, if you're adding layers onto wall, will the transmittance increase? Obviously no. The ability of heat transfer will reduce, the resistance will increase. For example, now we are experiencing winters in most part of our country, so we put on multiple layers. You put on a thermal, you put on a shirt over it, over that you put a jacket over. So why do you put multiple layers? Because you want to increase the resistance for the heat loss. You don't want your body's heat to go outside. You want to trap that heat, right? So that's what we are considering over here. U value is not additive, but the resistance offered to heat transfer is additive. Overall resistance of the wall will be resistance offered by the first layer plus resistance offered by the second layer, and so on. And also there is something called a surface resistance. Now I'm not going into the detailed approach of it, but in simple terms, you can remember there is also something called a surface resistance for both the outside and the inside surface, right? So that's the basic formula based on which you calculate U value cannot directly be calculated for a multi-layered wall. Rather, you calculate R value, the resistance of the wall, is surface resistance of the outside surface, plus add the resistance of all the layers and add it with the surface resistance of the inside surface ultimately. And resistance of any surface, or resistance of any layer, is calculated as L by K. For example, resistance of the first layer will be L1 by K1. Resistance of the second or any nth layer will be Ln by Kn. L by K is called as resistance of that particular layer. So for any given layer, you can substitute L by K to find out the value of the resistance of that layer. So you can rewrite this formula, the second formula. The other approach of writing it would be 1 upon U value of the wall, because R is nothing but 1 by U. R and U value are reciprocal of each other. So you can write R value as 1 by U is equal to surface resistance of the outside surface plus, instead of R1, you can always write L1 by K1. Thickness divided by the thermal conductivity is called as resistance, plus so on Ln by Kn. You need to add L by K for all the layers and add the surface resistance of the inside and the outside surface. So this is the final formula, which is an important again formula which has been asked multiple times with 2 marks in the examination. First is Q is equal to U into A into delta T. We'll solve some application. We'll look into some questions also and apply these concepts. So R value is surface resistance of the outside surface plus add the resistance of all the layers plus surface resistance of inside surface. In other words, you can write this as 1 by U is equal to add the surface resistances and add the resistance of all the layers. How do you find out resistance of any layer? L upon K. That's it, right? One last point over here. Sometimes in the examination, instead of directly giving you surface resistance, they will give you surface conductance, which again are reciprocal of each other. So you can remember surface resistance of outside surface can also be written as 1 upon surface conductance of the outside surface. Similarly, surface conductance of the surface resistance of the inside surface can be written as 1 upon surface conductance of. So the reciprocal of surface conductance is called as surface resistance. So what they do in the examination is sometimes they will give you thickness of all the layers. For some layers, they will give you the value of thermal conductivity. For some layers, they'll directly give you the resistance value. If they directly give you the resistance value, you'll just add it into the formula. Sometimes they'll give you surface conductance, sometimes they'll give you surface resistance. So various permutation combinations of the same formula will be asked in the examination. We'll practice some questions. It'll give you better confidence once we do that. For now, you can just make a note of this formula. There are 2 points. R value is surface resistance plus sum of all the resistances plus the surface resistance of inside surface. Similarly, you can also rewrite it as 1 upon U value is equal to add the surface resistance of inside and outside and add the L by K values, because L by K is nothing but resistance. Sometimes surface conductance will be given. In such cases, remember, surface resistance is 1 upon surface current. Let me write down over here. SR is surface resistance. SC is surface conductance. So these are the points you can remember. There's one last point with respect to U value. Conductance and transmittance are synonyms. Dheeraj, conductance is a term we use for one particular layer. Like for example, transmittance is a term we use for an overall building component. When you measure the transmittance of one particular layer, that is K by L basically, reciprocal of resistance. That's called as conductance, right? I'm not using the word conductance over here because it might create confusion. So you can just forget. Basically, we at KP classes focus on concepts always, right? In our coaching, if you have studied with us, or there are some students who are only taking up this revision session also, I'm sure, but those who have taken our classes are well aware about the approach. We derive each and every formula. Where are we getting this formula from? Because gate exam is a conceptual examination that twists the question. It will not always be a formula substitution question. But with the time limit of this revision session, we are assuming some basic points, so that's the reason I'm writing why exactly R is L by K. So that you need to derive, and that derivation we have, if you have attended the classes, you remember we have already done that derivation from Fourier's law of heat conduction. Anyways, so that's an approach which that's a quick revision of the U value of a multi-layered wall. Let us now look into the last point under U value and practice some questions after that. Last point under U value, the third important numerical concept with respect to U value is U value of a wall with multiple surfaces. U value of a building component with multiple surfaces. Or in other words, you can say U value of a multi-surface wall, not multi-layered, but multi-surface building component. It's like U value of multi-surface wall or building component. What do we mean by multiple surfaces? Can we have recording of this session? Angel, absolutely. The recording of the session, a backup of the session is available. Will be available once the session is done. You'll get an access to the recording of it by probably tomorrow on your mobile app. On the KP Gate classes mobile app, you can find it. So, U value of a multi-surface wall now. What is a multi-surface building component? Let us say this is a wall, for instance. You say this is a wall. It can have a door over here, a window over here. So these are multiple surfaces. These are not multiple layers. It's not like door के पीछे window है, window के पीछे wall section. ऐसा नहीं है. It's not that way. You don't have door, then the window, then behind it the wall section. It's all on the same surface. You have a wall surface on which you have the door, and also everything is in parallel on the same surface. In such cases, how do you calculate the U value of such multi-surface wall? Let us also look into that. For that, you'll need to know the U value of each and every component. Let us say U value of the door is U1, area of the door is A1, U value of the window is U2, and area of the window is A2. U value of the wall section is U3, area of the wall section is A3. Remember, when I say area of the wall section, I'm only talking about the area of the wall, that is this part, not the door and the window. So that's A3, the area of the wall section. Right? So for every surface, you'll need to know the U and the area of that particular material or that particular section. If you know that, you can find out the overall U value of the wall as U1 into A1 plus U2 into A2 plus U3 into A3 divided by total area, that is A1 plus A2 plus A3. This will give you the U value of the wall. Now again, I'm not deriving it, I'm just revising the concept over here. The derivation, however, is simple, but I'll not go into that details. If we keep on deriving each and every formula, we'll not be able to revise everything in these 3 hours. So our focus is on revising things here. Right? So U value is U1A1 plus U2A2 plus U3A3 upon A1 plus A2 plus A. What happens if there are 4 surfaces? What if there's one more window? You'll get one more term, U4A4. So for U value of a wall, you can also rewrite it like this: U1A1 plus so on for all the n surfaces divided by A1 plus A2 plus so on till AN. For all the n surfaces, you'll need to do that. That's a generalized formula. So there are two formulae for U value. You can have U value of a multi-surfaced wall. So if you're getting a question where there are multiple surfaces on a wall, you use this formula. If you're having multiple layers in a wall section or a building component section, you will use this formula. So basically, what is R again here? R1, R2, R, all these are the reciprocal of U values. So remember, U value is not directly additive in nature. Let me also write that here. U1 plus U2 will not give you the overall total U value. What will give you the overall U value is reciprocals of it. 1 upon U total, that is equal to 1 upon U1 plus 1 upon U2 plus so on, whatever layers you're having. The reciprocals of U value are additive in nature because reciprocals of U value are called as resistance R value. Right, so that's a quick revision of the U value based concepts. Why should we all focus on finding out the U value of a building component? It is because you use that U value, multiply it with area and delta T, you will get the heat gain through that wall, through that building component, right? So that's a quick revision of the concepts related to the thermal quantities and U value. Let us now practice some questions on this concept from the past gate examination. So let us take up some questions, starting with a very simple one, and we'll also look into some good and difficult questions from past gate as well in the course of this session. So firstly, the 2 marks quiz. This is a 2 marks numerical from 2014 gate examination. You can also try to solve it in parallel to me. A brick wall 19 centimeter thick has a thermal conductivity of 0.811 watt per meter degree centigrade. The outside and inside surface conductance is given, not surface resistance. Surface conductance is given, 16 and 8 respectively. They're asking us the U value. So how many layers do you have? Other than the surfaces, you have only one layer, that is brick. There's only one layer of this wall over here. That's a brick layer. For this brick layer, the thickness is given. The thickness of the brick, let me write it as LB. L is what we are using for the denotation of thickness. LB is given as 19 centimeters. You'll need to solve everything in meters. Finally, answer is required in watt per meter per degree centigrade. So convert this into meters. This will be 0.19 meters. That is the thickness of the wall. What is the material thermal conductivity? What is the thermal conductivity K of the brickwork? That is given in the question as 0.811 watt per meter degree centigrade. Other than that, the surface conductance values are given. Surface conductance of the outside surface is given as, let us say it is 16. This is given as 16 watt per meter square degree centigrade. And for the inside surface conductance of the inside surface, that is given as 8 watt per meter square degree centigrade. These are the values given. 4 things are given. Let us now try to find out the U value of this wall. What is the formula we use? 1 upon U value of the wall is equal to 1 upon surface current. Because if surface resistance is given, you will directly add it into the formula. If the value is surface conductance, you'll add the reciprocal. I see already answers coming up. 2.37 must be correct answer. So 1 upon surface conductance of the outside surface plus LB upon KB. L upon K you will add because L upon K is nothing but the resistance of that layer, plus 1 upon surface conductance of the inside. So use this, you will get 1 upon surface conductance of the outside surface is 16, 1 upon 16 plus 0.19 is the thickness, thermal conductivity is 0.811 plus 1 upon surface conductance of the inside surface is 1 upon 8. So you can use your calculators and simplify this. How much are you getting 1 by U as? Adding these three quantities, 1 by 16 plus 1 by 8 plus 0.19 divided by 0.811. Can anyone calculate and tell me the value? 0.42177. Okay, you are getting this as 0.4217. I would recommend you all, every one of you, remember, when you round off anything before, this is not the final answer, right? Anything you round off before the final answer, round off to at least 4 decimal places correctly. So this will be 8, not 7, right? Because it is 7, 7. So this becomes 8, 4218. So try to round off to 4 decimal places correctly. So that will always give you an answer in the range. So U value of the wall will be 1 upon 0.4218. The reciprocal of it will be U value because this is 1 by U. So U value will be the reciprocal of it. So I think the answer is coming out to be 2.37. That was the answer you're getting. Watt per meter per degree centigrade. That will be the in the range of the answer. 2.37 is the correct answer. So that's a very simple question based on the calculation of U value. Let us now look into few more questions, slightly difficult ones, let us say, or different forms. We'll try to use or apply questions of different types. So the next type of question, this again is, if anyone has any doubt, you can put it into the chat. Uh, uh, Recording will be available if you missed out something, however. So in the next question, this is a 2 marks question from GATE 2019 question paper. A 5 into 5 into 3 meter room has four 230 thick external brick walls. The size of the room is given and the wall thickness is given. Total wall penetration is given as 10 square meter. Penetration is nothing but doors and windows. That is said to be 10 square meters. That's the area of windows. The temperature difference between indoor and outdoor delta T is given as 2 degrees Celsius. So let me write delta T value. Delta T is given as 2 degrees centigrade. The air-to-air transmittance values for 230 brick wall and 200 thick aerated concrete block wall is 2.4 and 1.7. So there are two options for the materials of the wall. So U value, if you are using brick wall, that U value is given as 2.4 watt per meter square degree centigrade. If you are using autoclave concrete block, let me write ACB. U value of that autoclave concrete block or aerated concrete block, that aerated concrete block is given as 1.7 watt per meter square degree. There are two options, either brick or aerated concrete block. So U values are given for both. Then what else is the given information? The brick walls, if the brick, now the last question statement is important here. If the brick walls are replaced with the aerated concrete block walls, if you're replacing brick with aerated concrete block, then what will be the change in the conductive heat flow through the wall? They're asking how much will be the difference or change in the heat gain. That change in the heat gain, because see, if you're replacing the walls with some other material, obviously the heat gain will change, because aerated concrete block is having less thermal conductivity, so it will give you less heat. How much less heat will come? That's what they are asking. So for that, you'll need to find out the heat gain in both the options one by one, right? So for that, how do you calculate heat gain? Heat gain in case of brick wall, what will be the heat? It will be U value of the brick wall multiplied by area into delta T. So they are saying that the temperature difference is given, and then if the brick wall are replaced with the concrete block wall. So U into area into delta T, that is what we need to do. So delta T is directly given in both the options. You will consider the same delta T because there is no different delta T given in both the cases. Area, you will just need to find U values directly given in both the cases. So our focus first should be on finding out the area. And because we are talking about only walls here, what will be the area of the walls? Area of walls will be equal to 2 H into L plus B. That's the formula of wall surface for a cuboidal room. 2H into L plus B. But remember, from this you need to subtract 10 square meter. Why will I subtract 10 square meter? Because 10 is already doors and windows. That penetration has to be subtracted. So what is the area of the walls you're getting? 2 into height is given as 3 meter into L plus B is 5 plus 5. From this overall value, you need to subtract 10. So what is the value of A you're getting, area? It is 2 into 3 is 6. 6 into 10 is 60. 60 minus 10 is 50. Absolutely correct. 60 minus 10. Most of you have given the answer correctly. Area is 50 square meter. So you know the area, you know the delta T, you know the U value in both the cases. So area of roof add सृष्टि no roof add नहीं होगा, because question आप पढ़ो first statement में क्या लिखा हुआ है? Room has four 230 thick external brick walls, and they're only talking about the wall. Through the wall they are talking in the last statement. How much is the change in the heat gain through the wall? So you'll not add the slab because obviously slab is not made out of brick or ACC, aerated concrete block. As per the question, they're only talking about the walls here, right? That's the reason you only will take the wall area. So what will be the heat gain in case of brickwork? It will be U value of the brickwork, that is 2.4. Multiply. I hope Shruti, your doubt is clear. So 2.4, area is 50 square meter into delta T is 2. How much is this? 240 watt. That's the rate of heat gain in case of brickwork. Next, in case of aerated concrete block, It will be U value of the aerated concrete block into area into delta T. So U value of the aerated concrete block is 1.7. Area of the surface is 50 of the walls. Area of the walls will not change, right? So area of the wall into delta T is 2. So this will be 170 watts. How much is the change in the heat gain they're asking? Initially, it was 240 watts. If you're replacing it with aerated concrete block walls, you're getting only 170 watts. The change in the heat gain will be 240 minus 170. So how much is that coming out to be? 70 watts. 70 watts is the correct answer for this question. Change in the conductive heat gain. There is no rate. So generally, when you have questions in the gate exam which have a round figure answer, exact answer in the form of round figure, there will be no range generally. Generally, there's no range. So in this question also, there's no range. The answer should be exact to the point 70. Nothing other than that. Even 69, you'll lose your marks for the question. So that's about this question. It is based on this concept of Q is equal to U into A into delta T, the first formula we discussed, right? Let us now look into the next one, the next question. This one, it is again a 2 marks question from 2021. However, this question was given marks to all because there is an error in this question, and that error, if you see, let us read through the question first. Using the following values of thermal conductance, surface conductance, thermal resistance, U value of the wall section is dash. They're asking us the U value. They have given the thickness of all the layers. How many layers are you having? First layer is plaster, second layer is brickwork, third layer is cavity, fourth layer is brickwork, fifth layer is plaster again. There are 5 layers here, as you can see in the brick section. And the thermal conductance is given as 1.2 watt per meter degree centigrade. So the error here is this is not conductance, this should be conductivity. That's an error in the question. Because of that mistake, this question was given marks to all. But let us make that correction. Let us make that correction ourselves. Let us say this is not conductance, conductivity. If you make that correction, then you can give the answer. So initially, when they gave the answer key, they have given it considering this as conductivity. They have given an answer key, but students had contested it, including we from our end also. We had contested in 2021 because it was an error in the question. They have considered it and have given it for marks to all. So it was given, marks were awarded to everyone irrespective of if you have attempted it or not. However, let's make that correction and solve the question for practice purpose. So the conductivity of the brickwork and the plastering are given. Surface conductance of both internal and external surface. It's written as internal twice over here. One is internal, one is external. The surface conductance of the internal and external surface are given. And then the thermal resistance value is also given. Thermal resistance for the cavity is directly given. Thermal resistance is given, right? So let us see. How do you calculate U value of a multi-layered wall? There's no direct formula for U value. Rather, there's a formula for the resistance, 1 by U. 1 by U value of the wall will be 1 upon surface conductance are given. So it is 1 upon surface conductance of the outside surface plus. Remember, there are 5 layers here. 5 layers. So you will add the resistance of all the 5 layers, R1 plus R2 plus R3 plus R4 plus R5 plus 1 upon surface conductance of the inside. That's the formula. But the resistance value is not directly given. There is L and K. So R is nothing but L by K. But remember, for the third layer, that is for the cavity part, the resistance is directly given. So this you will not change. This value is directly given. For the remaining, you will write L by K. So this will be equal to 1 upon surface conductance of the outside surface plus resistance of the first surface can be written as L1 by K1. Resistance of the second surface can be written as L2 by K2. Not surface, but layer. Second layer can be written as L2 by K2. For the third layer, you will directly write resistance because direct resistance is given here. Resistance is measured in meter square degree centigrade for watt. Plus, for the fourth layer, again it is L4 by K4. For the fifth layer, again it is L5 upon K5. And you will add the reciprocal of the surface conductance of the inside surface finally. That's the final formula which we will be using. All the values are given, so it is just formula substitution after this. So this is where it is a bit tricky. You will need to understand that R3 is directly given. That's where the uh, basic test of your concept lies in. So here there is an unnecessary information of the thickness of cavity. This is not at all required. There is no L3 is not required in the formula. It is directly R3 given. Right? Let us substitute the formula value 1 upon surface conductance of the let us say this is internal, this is external surface. Surface conductance of the outside surface, let us say that is 1 upon 9.5 plus L1 by K1. L is the thermal conductivity. L1 is thermal conductivity of the first layer. Let us say that is what is the thickness of the first layer? It is plaster, 10 centimeter, 10 millimeters it is. You need to convert that 10 millimeters into meters. So 10 mm in meter will be 10 divided by 1000. So that will be 0.01 divided with that the thickness in meters divided by K of the first thermal conductivity of the plastering layer. Thermal conductivity of plastering is given as 0.5 plus for the second layer, it is brickwork. 100 mm can be written as 0.1 meters divided by the conductivity is 1.2 plus for the third layer, R3 is directly given 0.17. You will add that without any thickness. L4 by K4 again it is same as the second layer 0.1 upon 1.2. Fifth layer is same as the second layer that will be 0.01 upon 0.5 plus 1 upon surface conductance of the inside surface, internal surface is 8. So you'll need to simplify this. Can anyone tell me how much are you getting this final value by adding all these? 1 by u, kitna, how much are you getting the value of 1 by u? Not the u, 1 by u value. Is it 1.65 or something else? 0.606, okay. 0.606, that's the value of 1 by u. Many people do this mistake also. They solve everything correctly, and in the 6069, okay, they do it correctly till here, and by mistake they'll put this value into the answer key directly into the box. Don't do that mistake. Remember, in the last step, with concentration, now you should be in a cool state of mind. If you're tensed and if you're in a hurry mode, you'll make such silly mistakes in the paper. So you need to focus. Those 3 hours of the examination, the most crucial part, it ultimately, whatever preparation you had, it ultimately ends up into those 3 hours, and you will have to be in cool state of mind. Revision plays the major role in having a cool state of mind in the examination. If you are confident, you will be in a cool state of mind. Remember, in the last step, u value of the wall will be 1 upon 0.6069. That should be 1.65, I think, in watt per meter square degree centigrade. That's the correct answer for this question. However, as I told you in the official question paper, it was marked 12 because of this mistake. This, I think I've made this typographical error over here. Internal, external was correctly given, but conductance was mentioned instead of conductivity. So it was a marks 12 question. So that's about this question. Moving on to the next one. This again is based on the same concept of U value. Let us also have a quick discussion of it. Once we are done with this climatology across, probably after around 1.5 hours, I'll give you a 2 or 3 minute break before we start with lighting and acoustics. Can you go back? Sure, Ritu. Let me know when you're done. If you have any doubt, you can ask me. Otherwise, let me know when you're done with it. So there's no use of L3 here. That's something which you can observe. Done? Okay. Chalo. Let us now move on to the next concept. This is one of those questions on U value from past gate, which can be considered to be a good question. Let us look into this. If a roof is treated with a layer of thermal insulation material, this was after 2 marks in 2015. Okay, see, there's some doubt. Will we get a physical calculator, or we have to use the on-screen Shambhavi? There is no scope for taking a physical calculator. You will have to use the on-screen calculator in the examination. It will be available in all the questions. It's not like it will be available on only few questions. That's not how it is. There will be an on-screen scientific calculator available for all the questions of all the parts. You can use that. I would suggest you all, recommend you all to use the on-screen calculator and have a practice of it. So you all are having access to the mock test. When you give that mock test, make use of the scientific calculator. Don't use a phone, or don't use the scientific calculator when you're giving the mock test. Try to use the on-screen calculator. It will give you a habit of using it in the exam. Uh, Even you can also check from the official GATE portal. They also give you the last year's test in the form of an actual test on the official GATE website. You can check out that official GATE website. There's a mock test over there. and you can use their scientific calculator and all to use it. It's important to write the final unit of the paper before solving it in the exam. Yeah, Vishant, you'll need to cross-check the measurement units for sure. It is always advisable to do it, but again, when you type the answer, you need not type this in the examination, the measurement unit. Anyways, uh, KP Gate app can't open in computers. Do you see the mock test I think you can give if you're having any technical issue? Just contact the number, they'll guide you through it. Mock test you can give it on computer also. Just the videos, I think you can watch it on the app, but the test you can give it on computer. Uh, just check with the, you can call the on the number for office and they'll guide you through it. Fine. Fiber has an answer already. Let us look into this question. The roof is treated with a layer of thermal insulation. The internal heat gain is reduced by 60%. If the roof is treated, they are saying the heat gain is reduced by 60%. U value of the roof slab without insulation is 3. Assuming a constant temperature difference between indoor and outdoor, the U value of the insulation layer will be dashed. That's the question. So there are two cases here, before insulation and after insulation. So if you consider the case of before insulation, let us consider before insulation. If you consider the scenario of before insulation, they are saying that there is a slab which is giving some heat gain. Let us say this is Q. Let me write it as Q before insulation, or let me write it as Q1. I think that will be enough. So before insulation is that first case. So Q1 is the heat gain. And what is the U value of the slab? U value of the slab is given as 3 watt per meter square degree centigrade. That is before insulation. Now after insulation, that's the second case. Okay, before we move on to after insulation, let us see what is the heat gain before insulation. Heat gain will be U value of the slab multiplied by area multiplied by delta T. There's only a slab layer, there is no insulation. So U of slab into area into delta T. That is the heat gain in the first case. In the second case now, to reduce the heat gain, what they have done is they applied an insulation layer on the top. On the same slab, they have applied an insulation layer. Now the heat gain in the second case, Q2, is they're saying it is reduced by 60%. So if something reduces by 60%, the remaining part will still be 40%. So it is given heat gain after insulation. Q2 is heat gain after, you can write if you want, heat gain after insulation. Heat gain after insulation Q2, that is given as 40% of Q1. How did they say 40%? They did not directly mention 40. They said it reduced by 60%. If something reduces by 60%, you're left out with 40%. That you should understand, 40% of Q1. So this will basically be 0.4 into Q1 is nothing but this value is U value of the slab. It is given as 3. So this is 3 into A into delta T. You can substitute this value instead of Q1. So it is 0.4 into 3 into A into delta T. Now what is Q2? Q2 is nothing but U value of the second slab. So the U value of this overall second slab, let us say that is U2, because the slab has two layers in it, the original slab and the insulation. So Q2 can be written as U value of the second slab, or the new slab you can say, into area into delta T. That will be equal to the U value of the second. What is the second slab? It is a new slab because you treated it with insulation now. It's a new slab which you get. U value of that new slab into area into delta T will be 0.4 into 3 into area into delta T. So 0.4 into 3 is nothing but 1.2. So this will basically be 1.2 into area into delta T. Delta T can get cancelled and area can be cancelled on both the sides. So what are you getting over here? You're getting U value of the second slab, or U value of the new slab is 1.2 watt per meter square degree centigrade. You're getting U value of the new slab is 1.2 watt per meter square degree centigrade. This is what we are getting. But is this the final answer? No, this is not the final, because they're asking us the U value of the insulation layer. So generally, when you measure U value of a layer, technically it is called as conductance. It's not called as U, because you measure U value for the overall building component. When you measure it for a single layer, it is generally called as the conductance of the layer. But anyways, you can also call it as U value of the insulation layer. So U value, as you know, you cannot add them. U value of the second, you cannot say U value of the second slab is U value of the original slab plus U value of the insulation. Can you do it? No. U value is not additive, but the reciprocal of U value is additive. You know that, right? So instead of this, what do I write? U value is not additive, but the reciprocal, 1 upon U value of the second slab or the new slab, that is 1 upon U value of the original slab plus 1 upon U value of the insulation layer. So you know the U value of the second slab, that is 1.2. You know U value of the original slab that is given in the question as 3. U value of the insulation that you have to calculate. So now you can simplify this. This implies 1 upon 1.2 is equal to 1 upon 3 plus 1 upon U value of the insulation. There's one unknown, one equation. You can simplify and find the value of U insulation. So 1 upon 1.2, I think it will be 0.8333, and this is 0.3333. If you subtract that, so you will get, if you simplify this, let me erase this part over here. Let me simplify that portion. Hope you are able to follow. So they are testing two concepts over here. Can't we just do Q after is equal to 60% of Q before? Anushka, no, it is reduced by 60%. They're not telling heat gain after treatment is 60% of the original heat gain. They're telling the heat gain is reduced by 60%. So it is not 60% of before. So it's like 40% of before, not 60, because it is reduced by 60%. If they give in the question, if they would have written, if the roof is treated with a layer of insulation material, the internal heat gain is 60% of the original heat gain, then you will take it as 60% of Q before. It is reduced by 60%, so you will take 40%. I hope that's clear, Anushka. So let me simplify this part over here. After this step, 1 upon 1.2 will be 0.8333 is equal to 0.3333. That's the value of 1 by 3 plus 1 upon U value of the insulation layer. Right, so this implies 1 upon U value of the insulation is equal to 0.5. This goes to the other side and subtract, it will be 0.5, which is 1 by 2. So this implies U value of the insulation layer is 2 watt per meter per degree. Many people have observed they do it correctly till here and write this as the answer. So you should not do such silly mistakes in the examination. Don't just write down the answers once, because they're asking U value of the insulation. They're not asking U value of the slab after treatment. What is this? It's U value of the slab after insulation or after treatment. That's not what they're asking. I hope this question is clear to you all. That's a bit tricky, which is based on this concept and also the concept that resistances can be added but not the U values. Any doubts, you can put it into the chat. If it's given reduced to 260%, then will absolutely yes, Ponnimanturai. Absolutely, guy. What you said is correct. If they have mentioned it is reduced to 60%, then you will take it as here you will take 0.6 into 3 into area into delta T. Then the answer would be 1.8 over here instead of 1.2. And accordingly, you will get a different answer. So that's how you solve this question. Let us now move on to the next concept. The last question on this concept of U value, this one. This will be the last one which we will be practicing with respect to the U value concept which we have studied. After this, we'll look into some theoretical questions and some other concepts of solar architecture with respect to climatology. So this one, an unplastered brickwork. This is also a good question. This was asked for 4 marks in 2012. So earlier, till 2014, I think there were questions of 4 marks, or at least till 2013. There were questions of linked paragraph-based questions, but now you don't have such questions in the paper. However, the concept is same. Solving it is important. So there are no NAT questions here. It is MCQ. Nowadays, you get NAT questions without options. So that is fine. The pattern is different, but the concept is same. So let us solve the question to learn the concept over here. An unplastered brickwork has a resistivity of 0.83. What is resistivity? 1 by K. 1 by K of the brickwork is given as 0.83 meter degree centigrade per watt. That's the given. This is 8 over here. Right? 1 upon K of the brickwork is given in the first statement. For a 230 mm thick brick wall, so what is the thickness of the brick wall? Thickness is given as 230 mm. In meters, 230 mm will be 0.23 meter. That's given. Inside and outside surface resistances are given. They have given us the surface resistance of the inside surface, that is given as 0.123. I'm not writing the measurement unit. It is meters per degree centigrade per watt, the resistance. Surface resistance of the outside surface is given as 0.1. meter square degree centigrade for what? Same over here, right? So that's the value. These are the four values given. What are they asking? They're asking us the R value of the wall. They're not asking U value. They're asking us the R value of the wall. So let us try to solve that. R value of the wall will be equal to surface resistance of the outside. You'll add the surface resistance, not the reciprocal of it. Surface resistance of the outside surface plus LB by KB. There's only one layer. Plus surface resistance of the inside surface. So what will this be? Surface resistance of the outside surface is 0.1 plus LB by KB is nothing but 0.23 into 0.83. You will multiply it because 1 by KB is given. KB is not given. You will not divide it by 0.8 because it is directly 1 by K given. You will multiply it over here plus surface resistance of the inside surface, that is 0.123. So add these three things. What is the answer you're getting? So many people can happen to do a mistake over here in this step. LB by KB is nothing but LB into 1 by KB. 1 by KB is directly given to us. So you don't divide it, you will multiply it 1 by KB. So the answer over here will be 0.41. That's what you're getting. R value of the brick wall, that is given as, that coming out to be 0.41 meter square degree centigrade for what? A is the correct answer for this question, not B. Right? So remember this point. It is LB into 1 by KB. 1 by KB is not given. 1 by KB is directly given, not KB. So remember that point. Next, second part of the same question. It is a continuation. Brick wall has an overall dimension of 6 into 3, a 1 meter into 2 meter window assembly with the U value of 2.5, and 1 meter into 2.1 meter door assembly with the U value of 1.25, and overall U value is being asked, right? So there are door and window in this wall. Can anyone tell me now, is this a wall section with multiple layers or multiple surfaces? Which formula will be applied over here when you have a door and a window? Multiple layers or surfaces? Obviously the concept of surfaces, because these are on the same surface. So how do you apply the formula? You will know the value of U1 and A1, U2 and A2, U3 and A3, right? So let us write down what each of those are. U value of the first surface. I'm considering first surface as door here. What is U value of the door? It is given in the question as 1.25. Area of the first surface. What is area of the door? It is 1 into 2.1. So it will be 2.1 square meter. Similarly, U value of the second surface is given as 2.5. Area of the second surface will be 1 meter into 2 meter. So 2 square meter is the area of the window. Similarly, U value of the third surface. Now, U value of the third is wall section. For wall section, you know the R value. So what will be the U value of it? Can anyone tell me what will be U value of the wall section? It will be 1 upon 0.41. How much is that? 2.415. Let us say 2.42. I'll write 2.42, 2.43, right? 2.42 लिख लेता हूँ मैं. So this is 2.42. I am not cross-checking. I expect you have given a correct answer here. 1 upon 0.41 is 2.42 I am taking. Area of the third surface will be, overall area is 18, 6 into 3. Overall area is 18. But what will be the area of only brickwork? It will be 18 minus 2 minus 2.1. The door and window you'll need to subtract. So this will be 13.9 square meter. So from this, you can now find out the overall U value. U1 into A1, it is 1.25 into 2.1 plus U2 into A2, it will be 2.5 into 2 plus U3 into A3, that will be 2.42 into 13.9 divided by the total area. Total area is 18 square meter. So you can simplify this. 1.25 into 2.1 plus 2.5 into 2 plus 2.42 into 13.9 divided by 18. So what is the answer you're getting finally? 2.3, 2.28 you're getting by simplifying this. That's the correct answer in watt per meter square degree centigrade. 2.3 from the given options. B is the correct answer here. A is the correct answer over here, right? So that's how you solve this question. So that was about the last question on the concept of U value. I hope the concept of thermal conductivity, thermal resistivity, thermal conductance, thermal resistance, these four terms, their definitions, measurement units, and the three formulae based on these terms, I think this part is clear to you all. We have also solved good enough number of questions. So this is a area from which probably questions are generally, so it's highly probable that you get a question from this part generally. Sure, Vaishnavi, U3. So what is the third part here? Third part is the brick section, this part, and this is a continuation question. So in the last question, they gave you details about that wall section. That wall section there, the resistance is calculated to be 4.41. But what is resistance? Resistance is nothing but 1 by U. So this implies U is equal to 1 by R. R is 0.41. So 1 upon, so it's a continuation question. You take data from the past question and solve it. Is that clear, Vaishnavi? R is 0.41. I've calculated 1 upon 0.41 and that's how you got 2.42. Okay. Thermal conductance and thermal transmittance used interchangeably. Yes, thermal conductance and thermal transmittance are similar, but not exactly same. The only difference is you can interchangeably use them, but the only difference generally is thermal conductance is a term you use for one particular layer. You don't use it for the overall wall. And U value, that is thermal transmittance, you measure it air to air generally for the overall wall. That's the only slight difference, but the measurement unit for conductance and transmittance is same. It is watt per meter square degree centigrade in both. Is A1 overall area including doors and windows? Uh, Purvasha, right? Purvasha, A1 here is area of the door only. In the denominator, yeah, total area is overall area. A1 plus A2 plus A3. A1 is just 2.1. That's the area of the door. Area of door is 1 into 2.1, right? These questions come in general question also. Just meet. It can be asked in both, uh, but it is probably it's highly probable that you'll get in the architecture part generally, right? But you can also, there have been questions on thermal quantities like thermal damping in the common part as generally you will get in architecture part, right? So that's about the U value based questions. Let us now move on to the next concept. Let us look into some theoretical questions. Can you please repeat difference between thermal conductance and thermal transmittance? Sure, Surbi, right? I can repeat it for you. So U value particularly, let me tell you the difference between thermal transmittance and thermal conductance. U value, this is measured for a building component, right? Transmittance is measured for a building component. A building component can have multiple layers. Let us say there are three layers. Let us say there is a brickwork, there is some plastering, and there is some cladding on it. This cladding layer, this is say plastering layer or something, and let us say this is brickwork. Let us say there are three layers on a wall. Now, when you measure the overall thermal transmittance from air to air, you use the term U value. U value is for the overall wall. But when you measure the reciprocal of resistance of one particular layer, you can have resistance of brickwork plus resistance of plastering plus resistance of cladding. That will give you the resistance of the wall. And the reciprocal of the resistance of the wall is called as U value of the wall. So that's about U value. That's about thermal transmittance. For each of these single layers, the reciprocal of the resistance of a particular layer, that is called as conductance. Conductance of a layer. In simple terms, U value of a particular layer is called as thermal conductance. That's the difference between conductance and transmittance is for overall building component. For a particular layer, you don't generally call it U value. It is generally called as conductance of the layer, the reciprocal of the resistance. But generally, the terms are interchangeable, but that's a technical difference between conductance and transmittance. The measurement unit is same for both. Is that clear to be? Okay, thanks for the confirmation. Uh, Anand, see if you can connect to a better internet connectivity. I think that should solve. Generally on Zoom, when you have a lower bandwidth connectivity, generally it shifts to low quality video. Uh, so try to do that. I think that should solve your problem. Moving on. Let's now look into some theoretical questions over here. This is a question from 2022. Uh, Which of the following helps in keeping direct solar radiation out of the building? So they're asking what are the components which this is a multiple select type question which can stop the radiation. Mashrabia, yes, Mashrabia is the component which stops it. What is Mashrabia? It is a window which projects a type of oriel window which basically projects out of a wall and has jali components in it. It is similar to the jharokas in Rajasthani architecture. It is similar to that. Badgir is not a shading device. Malkuff is not a shading device. Malkuff and Badgir, these are basically wind towers. Wind catchers or wind towers are called as Badgir and Malkuff. Shajja is again an answer. Shajja is a shading device. So they're asking which are the shading devices. A and D will be the correct answer. Mashrabiya and Shajja. Next one, this again is a 2019 question for 1 mark, a simple theoretical question. The solar protection system consisting of fixed plates or grids outside the building facade in front of openings is called. It's referred to as bray soleil. Bray soleil is a shading device. It's a term used for shading device in architecture. So bray soleil basically is a term popularized by architect Le Corbusier. It's a French term for sunbreaker. A literal translation of this English word sunbreaker to French will be bray soleil. That's how the word became popular in architecture. Bray soleil, if you look into designs by Le Corbusier, particularly in many of his buildings, you see bray soleil outside the outer wall of the building. It's a shading device. Next one, walls of high thermal inertia are suitable for which climate? Hot and dry, hot and humid, thermal and cold. Walls of high thermal inertia, basically those walls which cannot heat up quickly. Those building components which do not heat up quickly are most suitable for hot and dry. Because in hot and dry, you should use building components which can insulate the building, which are not getting heated up quickly. So hot and dry is the answer for this, most appropriate answer for this question. Right. So remember, as the climate responsive design for hot and dry climate is considered, you will need to use building components which do not get heated up quickly, which are called as walls of high thermal inertia. Like for instance, insulating materials, thick walls, those are suitable for hot and dry climate. Uh, any tips and tricks for all type of MSQ questions? Apurv, I think if you're confused in MSQ questions, the best approach, which generally works for MSQ questions, is the elimination approach. You can try to eliminate the incorrect options. That way, you will be in a state to have a more accurate answer. You'll not miss out on any options. If you work with elimination approach, generally that works. So try practicing that in your mocks and you'll get an understanding if it works for you or not, right? Please explain second one again. Sure. Yes. The second question they're asking us a protection system consisting of fixed grid outside the building facade in front of openings. So if there's a building facade, there are openings. A grid in front of that, which generally is used for shading that. So not only for building openings, generally in the on the outer wall, you can have these vertical and horizontal elements. If you look into the designs by Le Corbusier in Chandigarh and all, you see a grid of RTC slabs on the outer wall. That is with the motive of shading. Such grids are called as bray soleil. Bray soleil is a broader term which is any type of shading device generally. Even a jali can be called as a bray soleil. So louvers can be called as bray soleil, absolutely. Pergola can be called as a bray soleil. Any shading device with grid which basically stops the solar radiation, that's called as bray soleil. I think that answers your question, Yash. I would suggest you to look into some designs of Le Corbusier, particularly the ones in Chandigarh, Palace of Assembly and all. You'll get a better understanding on how it looks. I have a doubt in what happens if we put this wall in cold areas. Vaibhav, so in cold areas too, absolutely in cold areas also you need thick walls. In cold areas also you need those walls which basically trap the heat inside. It does not allow the loss of heat. But in terms of walls of high thermal inertia, we're talking about walls which do not get heated up quickly. Walls which do not get heated up quickly is more suitable for hot and dry only, because in cold you can also use those walls or those materials which can get heated up quickly. You want the walls to be heated up quickly, you just want to trap the heat, right? So both are different. the end outcome might look similar, but it's not a necessity in cold climate to have high thermal inertia, but it is in hot and dry to have high thermal inertia walls. Hope that answers your question. Yep. Umesh has a question. Drum wall, solarium, tomb wall, all these work on the same principle. What is the difference between them? Tomb wall and drum wall work on the same principle. Both work on the same principle of thermal storage. Solarium, on the other hand, it is basically any room which is exposed to solar radiation. So I would not say solarium exactly works on the same principle of thermal storage, because solarium works on the principle of exposure to solar radiation. But yes, the remaining two work on the same principle of storing the heat, thermal storage. I hope that answers your question, Bhumesh. Chalo, let us now move on to the next concept. A few questions on solar architecture. Solar architecture is basically that part of architecture which focuses on sun angles and sun orientation. So let us look into this. The concentric circles in sun path diagram represent dash. So you need to know, in a sun path diagram, there are four things: altitude angle, azimuth angle, day of the year, hour of the day. All the four are represented. But what is represented on the concentric circles? Concentric circles, many say altitude angle, and that's correct. So the concentric circles, make a note of this in the sun chart. Concentric circles represent the altitude angle. Altitude angle is a measure of how high the sun is. If the sun is high in the sky, the altitude angle is higher. If the sun is just on your eye level, let us say the sun is just rising from the horizon, then the altitude angle will be almost zero at the horizon. So the angle which you look at, so if you are looking at the eye in this angle, it is zero altitude angle. If you're looking upwards, then the altitude angle is high. So altitude angle is represented on the concentric circle. That will be the answer for this. But let us also look into what are the other things. The angle represented on the external circle. There are some angles over here: 170, 160, 180, 140, so on. So these angles which are represented on the peripheral circle, that is azimuth angle. So the angle measured on the peripheral angle on the external circumference, that is referred to as azimuth angle. It is basically angle with reference to north or with reference to south, that's called as azimuth angle. Day is measured on the sun path. You can see there's one sun path highlighted. These are various sun paths. The sun path on the top, this is summer sun path. Summer sun path of the month of June, July, that's on the top. Winter sun path is at the bottom. This is December, November, the winter sun path. It will be shorter. So the sun path is represented on the sun path represents the day of the year. So the sun path lines represent day of the year. You can see in this path also dates are written: March 21st, February 21st. Dates are mentioned on the sun path lines. Hour of the day, hour of the day is measured on these vertical lines. So the vertical curves which cut over sun path lines. The vertical curves which cut over the sun path lines, those represent the hour of the day. So you can remember these points. You can get theoretical questions of how a sun path is read. So you can read sun path with these lines. In episode 23, they asked about radial lines intersect with month and time lines in sun path. Okay, so you can check that episode 23 paper also. So these radial lines, basically the angle on the periphery, that represents the azimuth angle. So you can also write this as the radial lines. Angle measured by the radial lines. That's the peripheral angle, that's azimuth angle. So these radial lines, those are measuring the angle on the periphery, that is azimuth angle. So you can remember these 4 points. Concentric circles is altitude angle. The angle measured on the radial lines is azimuth angle. Sun path lines define the day of the year or day of the say calendar. Vertical curves cutting over the sun path, they represent hour of the day. So these 4 points of the sun path diagram, you should have an understanding. In this revision, I'm not going into the details of the definitions of altitude, azimuth angle, and so on. Right? Let me now move on to the next one. This again is a question from 2022 question paper. This was asked in the common part in the 2022 year. So let us solve this question based on a thermal quantity called as thermal damping. So let us solve this question as well. The maximum and minimum indoor dry bulb temperature of a room is 38 and 34 degrees centigrade. So what is the So the maximum and minimum indoor temperatures are given inside a room. Maximum and minimum temperatures are given, and the corresponding outdoor maximum and minimum. At the same time, outside also there will be a temperature difference. So that outside temperature range also is given. 42 and 30 are the maximum and minimum outside the room. Inside it is 38 and 34. Outside it is 42 and 30 degrees centigrade respectively. They're asking us what is the thermal damping of the room. So thermal damping is something which is defined as the difference between outside and inside temperature range expressed as a percentage of the outside temperature range. So you can make a note on this definition. What is thermal damping? First, write down the definition. Thermal damping is measured for a building component or an envelope of a building. So thermal damping is defined as difference between outdoor and indoor temperature range. Difference between outdoor and indoor temperature range expressed as a percentage of outside temperature range. Why do we measure this? Thermal damping is a percentage basically. It will tell you how well a building component or a building envelope is resisting the outside fluctuations, outside temperature fluctuations. How well is the building component resisting those fluctuations? That is measured as thermal damping. So it is difference between outside and inside temperature range expressed as a percentage of the outside temperature range. Let us say the outside temperature range in this question, let us solve outside temperature range. Let us say that is capital T. Uh, that will be equal to, or you can write it as TO, outside temperature range. That is basically 42 minus 30. That is 8 degree centigrade. Similarly, inside temperature ranges, let us write it as TI. That is 38 minus 34. That is 4 degree centigrade. What is thermal damping? Difference between outside and inside temperature range. Outside temperature range is 8, inside temperature range is 4. So, acha, it is 12, right? 42 minus 30. Correct. Good that you're concentrating on. So 12 is the outside temperature. Thermal damping is outside temperature range minus inside temperature range expressed as a percentage of the outside temperature range. So it is outside temperature range into 100. That's the formula. You need not by heart the formula. Remember the definition. Difference between outside and inside temperature range expressed as a percentage of the outside temperature range. So that will be equal to outside temperature range is 12, inside temperature range is 4, divided by outside temperature range is 12 again into 100. So this will be 8 upon 12 into 100, 66 I think, 4 twos and 4 threes, 2 by 3 is 66.67%. That's the correct answer for this question. So it's based on what is the percentage of the difference between inside and outside temperature range with respect to the outside temperature range. So that's the answer, and I think most of you have solved it correctly already. Let us now move on to the next concept with it. I'll give you a small break after at say 3:30 or so. I'll give you a small break at 3:30, 5 more minutes. So the next one, this is a small quick question on the sun angle. So it is with respect to shading device, how to calculate the shading device projection length. So before we solve this question, let me give you a brief introduction on the shading devices part, and then we'll solve that question. So in architecture, there are two types of shading devices particularly. There's horizontal and vertical shading device. Let me first talk about a horizontal shading device. Horizontal shading device is basically something which, let us say this is a window. A horizontal shading device is something which you project at the lintel level. So it is a horizontal element like a chhajja. At the lintel level, you provide a projection. That's called as a horizontal shading device. How do you find out the projection length of a horizontal shading device? the projection length of horizontal shading device is calculated in terms of tan of the vertical shadow angle. So basically, if I draw the section of this window, let us say this is a window section. This is the projection of it, the chhajja. This projection length, what do we mean by designing the shading device? You should calculate this length of the projection. This length of the projection to shade the window completely. If say this is the last sun ray which is just touching the external part, that last sun ray should touch the base of the window. That's when you will shade the window effectively. If say this sun ray, the last sun ray which is just touching and creating the boundary of the shadow, angle made by that sun ray with respect to the horizontal, that is called as epsilon, the vertical shadow angle. So this value, this angle and this angle will be equal because these are two alternate angles of the transverse cut between two parallel lines. So based on the tan of this epsilon, if height of the window is h, in this right angle triangle, tan of epsilon, what is epsilon here? Epsilon here is vertical shadow angle. You can make a note of it. This is called as vertical shadow angle. That's called as epsilon, right? So tan of epsilon will be tan of this angle, this particular angle. Tan is always the ratio between opposite and adjacent side. So the opposite side is h upon L. So you can find out the projection length L is equal to height of the window divided by tan epsilon. This is how we calculate the value of the length of the projection. Now, where will I get the value of epsilon from? Or what is the formula for again tan epsilon? Tan epsilon is calculated from this formula. You can remember tan of the vertical shadow angle is equal to tan gamma. Gamma here is the altitude angle of the sun divided by cos delta. Cos delta is called as the horizontal shadow angle. Just like vertical shadow angle, you have horizontal shadow. I'm not deriving these formulae here. So gamma is called as the altitude angle. Delta here is horizontal shadow angle. How do you calculate delta? Delta is the difference between solar and wall azimuth. Alpha is called as azimuth angle. So we saw, where do we get this azimuth angle and altitude angle from? You get it from the sun chart diagram. So, so difference between solar and wall azimuth is called as delta, which is horizontal shadow angle. Substitute the value of the altitude angle and horizontal shadow angle. From that, you will get the tan epsilon value. So these are some concepts on solar architecture. Nothing other than this is important. So you can remember 3 points. So number one, horizontal shadow angle is difference between solar and wall azimuth. For you, if you get a numerical, the values will be given in the question, solar and wall azimuth. So difference between solar and wall azimuth is called as horizontal shadow angle. Tan of epsilon, tan of vertical shadow angle is tan gamma. Gamma is altitude angle. Tan of altitude angle divided by cos of delta. That will give you tan epsilon. Once you have tan epsilon, it is simple trigonometry. Apply tan and you'll get the value of L, the length of the projection. Let's practice a question. I know it's a bit confusing. Let's practice a question. I think that will give you a bit of clarity. Let's solve this question over here. A 1.2-meter high window is located on a south facing wall. So the height of the window is given 1.2 meter. For a south facing wall, generally the wall azimuth for south facing wall is taken as 180 degrees based on the south direction. However, let us move further and see if the solar azimuth angle is equal to the wall azimuth angle. They are saying solar azimuth angle is equal to wall azimuth angle. And the solar altitude angle, that is gamma, solar altitude angle is 60 degrees. The minimum depth in meters of the overhang required to completely shade the window is dashed. They are asking us the length of the projection L. Length of the projection, I just told you, it is h upon tan epsilon, height of the window divided by tan of epsilon. Because in this right angle triangle, if this is the length of the projection, and this value is epsilon, the vertical shadow angle, and this is height of the window. In this right angle triangle, tan of the vertical shadow angle will be h by L. This implies L is equal to height of the window upon tan epsilon. Right? We need to find out the value of tan epsilon and you'll get the answer. Let us first go from this information. You can find out tan epsilon. I told you what is tan epsilon. It is tan gamma. Gamma is altitude angle upon cos delta. What is delta? Difference between solar and wall azimuth. So delta in this question is Difference between solar and wall, because solar and wall azimuth are equal, delta will be 0. So the denominator over here is cos 0. So this implies tan epsilon is equal to tan gamma is tan 60 degrees divided by cos 0 degrees, because delta is 0. Can anyone tell me what is the value of cos 0? Cos 0 is 1. So this implies tan epsilon is equal to tan 60 degrees. Substitute that over here. Length of the projection is height of the window, that is given as 1.2 divided by tan 60. 1.2 divided by tan 60. Now tan 60 is root 3. Root 3 is 1.732, right? How is delta 0? See, I told you the definition over here. What is delta? Difference between solar and wall azimuth. And in the question statement itself, they are saying the solar azimuth is equal to the wall azimuth. Solar azimuth and wall azimuth are equal. That implies the difference between them will be 0. Delta is the difference between solar and wall azimuth, because they are equal. Solar and wall azimuth are equal as per the question. That's how it is 0. Is that clear? Student with the name iPhone 5, please try to maintain your own names in the session. That will be easy for me to understand who is asking the question. I hope you got your answer. Okay, chalo. Next one. So let us continue this. 1.2 upon tan 60 is root 3. Root 3 is 1.732. 1 upon 2 divided by 1.732. How much is the answer you're getting? 0.69. She, okay, I will answer you also. 0.69 meter is the answer. Cos 0 degrees is 1. So, okay, you want to ask how is delta 0. So in the question they have given, right? So solar azimuth angle, that is alpha s, is equal to the wall azimuth angle. Both are equal, they said. Delta by definition is difference between solar and wall azimuth. If both are equal, the difference between them will be 0. That's how we got delta as 0, right? So this point, from this point, delta is the difference between solar and wall azimuth. Because they are given to be equal, difference will be 0. If two values are equal, the difference between them will be 0, right? That's how we got the 0. And you can use the calculator for any value. If you don't remember what is cos 0, you can use your calculator and check. It will be 1 cos 0. So that's how we solved this particular question. So it's a bit so I've just given you a quick revision by just noting down the formulae. I know it can be a bit confusing. You can study further on it, like what is vertical shadow angle, what is horizontal shadow angle, altitude angle, and azimuth angle. There are a total of 4 angles in solar architecture. Vertical shadow angle, horizontal shadow angle. There are 2 shadow angles, and there's altitude angle and azimuth angle for the sun. So based on these 4, we calculate the shading devices in architecture. So that's about it. The last question for this: uh, if we know it is south facing, why can't we take 180 minus 60 is equal to 120? Ritu, because it is south facing wall. What is the meaning of south facing wall? It means the wall azimuth will be 180 degrees. For south facing wall, wall azimuth with respect to north will be 180. And they said wall azimuth and solar azimuth are equal. So solar azimuth also is 180 degrees. So you can substitute this over here, 180 minus 180. You will get 0. You'll not, it's not 60 degrees, right? Okay, fine. Moving on, let us look at it. This is a repetitive question. Same exact question was asked in 2022 also. The concentric circles again represent altitude angle. B is the correct answer. So in addition to this, I will share you these questions which we are solving. I'll share you this particular document with the questions on the app. It will be you can access it under the study material tab. You can practice these questions. Let me not discuss the remaining ones over here. So I'll just tell you the concept. You can probably uh, try to solve these remaining questions yourself. There are 1 or 2 more questions. This question talks about the solar gain factor. So you can, this is a direct formula substitution based question actually. Solar gain factor of a building component, SGF is solar gain factor of a, you can just make a note of it, solve this question yourself later. I'll share you these questions for your practice. Solar gain factor of building component. of any building component, will be U value of that building component multiplied by the absorbance of the external surface upon surface conductance of the outside. I'm not deriving the formula here, but if you have attended the full lectures, I think you remember we have derived this formula. Where do you get this formula from? So in this formula, U is U value of the given building component. A here is absorbance of external surface. Absorbance, for example, if the external surface is black, the absorbance will be 1. So absorbance depends on the color basically. And the finish, ST naught is surface conductance of outside surface. So using this, in this question, surface conductance of the external surface is given, absorbance is given, U value is given. You can substitute the values and you'll get your answer for this question. So U into 8 absorbance divided by surface conductance is called a solar gain factor of a building component. Okay. So I think most of you are getting the answers 0.0396 or 0.04. I think that should be correct. There's one more concept. This question from 2020. This is based on solid temperature. So let me just tell you the formula of solid temperature. You can try to attempt this question yourself. Solid temperature is nothing but outside air temperature plus. So what is solid temperature? Let us say, for example, just explain you what is solid temperature. Uh, let us say the outdoor air temperature in a particular city. Let us say outdoor air temperature. The outside temperature, let us say, is 40 degrees centigrade. Now, if there are two people outside, one person is wearing a black shirt, the other person is wearing a white shirt. Will both the people feel the same level of temperature if they're standing on this, because 40 degrees and it is a sunny day with the solar radiation being received? Outdoor air temperature is 40 only. The outdoor air temperature is fixed. But the person with black and white shirt, will they feel the same time? Obviously, no. Who will feel that it is a higher temperature? Which colored shirt person will be? Obviously the one with the black shirt, because his shirt or his particular clothes will absorb the solar radiation. So solid temperature is that. Solid temperature is the temperature reading which combines the effect of outdoor air temperature along with the effect of the incident radiation. Because of the radiation, there will be some extra temperature with this particular person. So this is applied in architecture also. If there's a building with a dark exterior color, it will absorb radiation. That will increase the external temperature actual performance or actual consideration. So solid temperature is outdoor air temperature plus an extra value. That extra value depends on the absorbance. It depends on the intensity of the incident solar radiation into absorbance upon surface conductance. Just like the previous formula, TO here, this let me try to, so you can, this question is based on this formula, you can try to answer it yourself. T naught over here is outdoor air temperature. I here is intensity of solar radiation. A here is absorbance of external surface. SC naught is surface conductance of outside surface. So that's SC naught. I, A, and C naught. If you know these, solid temperature is outdoor air temperature plus I into A upon surface conductance of the outside surface. That is also something you can remember, right? So that was about the climatology part. Let's take a small 2 or 3 minute break and we'll look into the acoustics part after that. This question was asked in the common part. Vaishnavi, in 2020, there was no division. The question paper was not divided into common and architecture part. This is a 2020 question paper, right? So it's a common paper for everyone. This conductance and the one we used in U value are same. Absolutely, yes, Vaibhav, both are same. There's a mistake in this question. Actually, there should have been meter square degree centigrade. So that is missing actually here. Watt per meter square degree centigrade. Yeah, that's an incorrect unit. Our students in 2020, when have attended this paper, have claimed they have submitted a say they have raised the issue when there was a scope for contesting the answer key. We did raise an issue, but again, small errors sometimes they'll not consider for marks to all. They generally neglect that. In some cases, they up to the gate conducting authorities. So they have not given marks to all for this question. Anyways, we'll continue in 2 minutes. You can take a 2 minute break, 2 or 3 minutes, and then we'll continue with the next acoustics part. Okay, so let us continue now. The next topic we are looking into. So in the remaining part, we'll be looking into lighting and acoustics and revise those concepts also. First, let us deal with the acoustics part. Lighting and acoustics, both as per the official syllabus, are under the architecture part. Both lighting and acoustics, these are under the architecture part. So let us first look into the topic of acoustics. So the topic of acoustics, firstly, under this particular topic, there are mainly two areas of focus. One is with respect to reverberation time, and the second is with respect to the concept of sound level, sound intensity level. So let us first target the topic of sound intensity level and deal with that first. So firstly, the topic of sound intensity level. Sound intensity level, generally written as SIL, is measured in units of decibels. And sound intensity level in decibel is calculated using a formula. So for any sound, for example, I'm producing a sound. If someone is listening to me over there at any given point, let us say the person is speaking, and if I ask you what is the sound intensity level at this point, I ask you that. What is sound intensity level? It is nothing but the sound level measured in terms of sound intensity. So for that, you will need to know the intensity value firstly. The sound intensity at this particular point, you need to know sound intensity is measured in watt per square meter. So if you know the sound intensity, you can find out the value of the sound intensity level in decibels. Intensity is measured in watt per square meter. That's the measurement unit. So intensity is like the rate of flow of energy per unit area per unit time. How much energy, sound energy, flows per unit area per unit time. So it is measured in watt per square meter. The formula for sound intensity level will be 10 into log of. There's only one input value. To get this answer, you just need one value. You need to substitute into that, and that is log of I upon I reference. So you just need to substitute the value of I. So in this form, 10 log I 10 into log of I upon I reference. That's the formula for sound intensity level. So here, what is I? I is intensity of sound at that point, at whichever point you want to measure. You'll need to know the sound intensity at that point. This is measured in watt per square meter generally. So you need to know the value of sound intensity at that point in watt per square meter. If you know that, substitute the value in this formula. I reference is always fixed. It is fixed at 10 to the power of minus 12 watt per square meter. This is a fixed value. Why is it fixed at this particular value? Because this is the minimum intensity required to detect a sound. Human ear is capable of detecting a sound with a minimum intensity of 10 power minus 12 watt per square meter, and that's the reason this is taken as the reference point. So this is an important formula. Sound intensity level is given by 10 log I upon I reference in decibels. The answer will be in decibels. The input value over here is intensity of the given sound in watt per square meter. I reference is always 10 to the power minus 12 watt per square meter. You can use the scientific calculator to find the value of log directly in the examination. So that is one point. Other than this, you need to remember two more additional points with respect to sound intensity level. So this is point number one. Let us revise the important points and then solve some questions. The first point is sound intensity level is given by 10 log I upon I reference in decibels. I is intensity of sound at that point and I reference is 10 power minus 12. Second important point in the concept of sound level is referred to as inverse square law of sound intensity. The second point, you can take down the heading as inverse square law of sound intensity. Inverse square law of sound intensity. What is inverse square law of sound intensity? It states that sound intensity is inversely proportional to the square of the distance from the source. I here in this is intensity of sound in watt per square meter, obviously. R here is distance from the source. Distance, intensity of sound at a point, you can say, is inversely proportional to distance of the point, whichever point is under consideration, distance of the point from source. That's called as R. R is distance of the point from the source. So I is inversely proportional to square of the distance of the point from the source. That is something which you can remember as inverse square law of sound intensity. So this can be modified when you apply it into questions. You just need to remember this. I is inversely proportional to R square can be written as I is equal to some constant k into 1 by R square. So this implies I into R square is equal to some constant k. I into R square is equal to constant. So you can write this as in any case. So for a given source, let us say generally, so remember one basic point here. In acoustics with respect to decibels and sound level, any question you have which has to do something with distance, you will apply the second form, the second point which we are discussing. Any question, if there is something related to distance in that question, remember by default you will apply inverse square law in that question, because this is the only relation which you apply in acoustics to find out the decibel value based on the distance from the source. So I into r square is equal to constant. So if you're having a source, let us say there's a source which is propagating sound. Let us say this is point number one, this is point number two. There are 2 points. If you want to find the relation between these 2 points, let us say the intensity of sound over here is I1, intensity at the second point is I2. Let us say the distance from the source to the first point is R1, distance from the source to the second point, let us say that is R2. I into R square will always be constant. So you can write this as intensity at first point into distance of the first point square will be equal to intensity of second point, intensity at the second point into distance to the second point square, R2 square. I into R square will always be constant for a given source. It's not a universal constant. So in math, you have universal constant and you have constant for a given situation, for a given source, right? Universal constant is like pi. Pi is always 3.14. That's a universal constant. This is not universal constant. It is constant for a given source. If had it been a universal constant, I would have given you the value. ये 5 होगा या 10 होगा. I would have told you the value. It's not a universal constant. It is constant for a given source. For a given source, I1 into R1 square is equal to I2 into R2 square. That is something which you have to remember. This is called as inverse square law. So the application part of inverse square law, this is the formula. And as I told you, any question which has to do with decibel and has something to do with distance in it, remember by default that you will apply this formula in such questions in acoustics. That's something which you can keep in your mind. The third and final point with respect to sound intensity, at sound intensity level, the third and final point is with respect to adding the decibel values. Decibel values cannot directly be added. So it's like combining decibel values, combined effect of multiple sounds. If you're having multiple sounds, the combined effect cannot be added. Decibel values will not be added directly. You cannot say SIL of first sound plus SIL of second sound will not give you the total sound intensity level. Because sound intensity level is measured in decibels, it is a logarithmic scale. Logarithmic values cannot be added directly. Log 1 plus log 2 will not give you log 3. Log values are not log 1 plus log 2 will not be equal to log 3. So log values are not directly additive. So sound intensity level, which is based on a decibel scale, is not directly additive in nature. So how do you combine the sound effects then? If you're having multiple sounds, there are questions in the GATE exam where you'll need to combine the effect of multiple sounds. So that is done in terms of intensity. Intensity of the first sound plus intensity of the second sound will give you the total sound intensity. So this is the total sound intensity. So when you want to combine the sound levels, you will always add the intensity values and find out the total sound intensity. Once you get the total sound intensity, SIL, total sound intensity level in decibels, will be equal to, you will apply that formula 10 into log of total sound intensity divided by the reference sound intensity. Reference sound intensity is always fixed at e to the power of minus 12 watt per square meter. So remember, this is the third important point of sound intensity. So with respect to sound intensity level, we discussed 3 points. The first point is over here. The formula of sound intensity level is 10 log I upon I reference. The second important formula is inverse square law. I1 into R1 square is equal to I2 into R2 square. The third important formula is combining of the combined effect of multiple sounds. You cannot add the decibel values, but you can add the intensity values, and that total intensity you can convert it into total sound intensity level. So if someone asks you what is 60 decibel plus 70 decibel, so as an example, let us say someone is asking you what is 60 decibel plus 70 decibel. You cannot add and say 130 decibel will be the answer. That will not that's not how you add the decibel. So that's not how you find the combined effect. You'll need to convert this into intensity one, which will be 10 to the power of minus 6 watt per square meter. How do I know 60 is 10 to the power of minus 6 watt per square meter? From this formula. In this formula, if I substitute 60 is equal to 10 log I upon I reference is 10 power minus 12. If I substitute this, you can simplify this. 0 and 0 gets cancelled. This is to the base 10. What is the meaning of log? Base raised to the power of answer will be the value in the bracket. So 10 to the power of 6 is equal to I upon 10 to the power of minus 12. So this is based on simple math. What is log? Log is nothing but another form of writing exponent. Base raised to the power of the answer will be the value under consideration. So that's the base is 10 always when you, in this sound intensity level, we use log base 10 only. We don't write that 10 always. So base raised to the power of 6 will be, this is how you convert a, a log value into exponent. So this implies I is equal to 10 to the power of 6 into 10 to the power of minus 12. This will be 10 to the power of minus 6 watt per square meter. This is how you convert a decibel value to intensity, right? Actually, there's a shortcut for it. You can always do it this way. Whatever value you're having divided by 10, because you're canceling out the zeros. So if you want to convert a decibel value to intensity, divide the value by 10. Whatever you get, that subtract 12 from it and write it into the power of 10. Whatever you got, 60, so divided by 10, 60. Divide by 10, you'll get 6. Subtract 12 from it, minus 6. Write it in the power of 10. That's the shortcut, but it comes from these steps basically. Anyway, let me go back over here. So if you want to add these, 60 decibel will be 10 power minus 6 watt per square meter. 70 decibel similarly will be 10 to the power of minus 5 watt per square meter. What is the shortcut I told you? Divide this by 10, you'll get 7. Subtract 12 from it, you'll get minus 5. Write that in the power of 10. So that's the shortcut for it. So now you can add these intensities. Total sound intensity will be 10 power minus 6 plus 10 power minus 5. So you can take 10 power minus 5 common, it will be 0.1 plus 1. So you'll get 1.1 into 10 to the power of minus 5. This is the value you will get for the total intensity. Substitute this back into this formula. Instead of I total, write down 1.1 into 10 power minus 5. You'll get your answer. Total sound intensity will be 10 into log of 1.1 into 10 to the power of minus 5 divided by 10 to the power of minus 12. That is always fixed in the denominator. So this will be 10 into log of 1.1 into 10 to the power of minus 5 plus 12. This minus 12 goes to the numerator, it will become plus 12. So this will be 10 into log of 1.1 into 10 to the power of 7. You can simplify this using your scientific calculator. 1.1 into 10 power 7 is like after 11 you will be having 6 zeros. 1 1 0 0 0 0 0 0. Log of that value, multiply it with 10, you'll get your answer. I think most of you are getting 74, 70 point something. Is it 70 point something or 74 point something? Can anyone simplify this and tell me what is the answer for 10 into log of 1 1 and then 6 zeros? Log of 1 crore 10 lakh, multiply it with 10, 70.41. Okay, 70.41 is the answer. So this is an example. How do you add the decibel? 60 plus 70 decibel is not 130. It is 70.41 decibels. How is it 1.1? Okay, I will explain that for you, Aishwarya. This till here, I think it is clear. Total intensity is 10 power minus 6 plus 10 power minus 5. You can, because you're having plus here, you cannot say bases are equal, powers can be added. That is only in multiplication. So in these two terms, there are two terms here, 10 power minus 6, 10 power minus 5. If you take 10 power minus 5 common, if I take common 10 power minus 5, what will be left out here? You'll get 10 power minus 1. 10 power minus 1 is nothing but 0.1 plus, you'll get 1 here. 1 plus 0.1 is 1.1 into 10 power minus 5. So I'm taking 10 power minus 5 common in these two terms. I'm left out with 10 power minus 1. 10 power minus 1 is nothing but 0.1 plus 1. Right? That's how I got it. Is that clear, Aishwarya? Okay. So that's how you calculate the combined effect of sound intensity. Let us practice some questions from past gate on the concept of sound intensity and sound intensity level. So there are three concepts. Let me quickly revise those 3 points under sound intensity. The first thing is 10 log I upon I reference is the formula for sound intensity level. The second point is inverse square law, that is I1 R1 square is equal to I2 into R2 square. And the third important concept is the combined effect, which is always obtained by adding the intensities and not the sound intensity levels directly. I gave you an example also for that. Let us now practice some questions over here. A room is separated by a partition wall. There is a room which is having a partition wall in the center or somewhere. There's a room separated by a partition wall. The average intensities of sound in the source and the receiving side across the partition. So there is source and receiving side is across the partition. The intensity of the sound is given as, in the source side it is given 10 to the power of minus 4 watt per square meter. On the receiving side it is given as 10 to the power of minus 7 watt per square meter respectively. The transmission loss of the partition wall, they're asking how much is the loss in decibels. See, uh, you can find out, so the question here is, you should first find out what is the decibel value here, how many decibels of sound is experienced in the rooms with the source, how much is the decibel value in the receiving side. They're asking how much is the loss in decibel, how much is it reducing by due to the partition wall. Let us see. So the SIL on source side, let us first find out what is the sound intensity level on the source side. Intensity on the source side is 10 to the power minus 4. Sound intensity level on the source side will be 10 into log of intensity on the source side, that will be 10 power minus 4 upon the reference intensity, that is 10 power minus 12. So this will be 10 into log of 10 to the power of minus 4 plus 12. You bring that 10 power minus 12 to the numerator, it will become minus 4 plus 12. So this will be 10 into log of 10 to the power of 8. Right? So how many 10 to the power of 8 is like, you can find out what is log of 10 power 8, it will be 8. This will be 10 into 8, that is 80 decibels. That's the sound intensity level on the source side. I have calculated it to be 80 decibels. You can always remember log of 10 raised to the power of any number will be that value only. So log of 10 to the power of x will be x directly. So it actually is based on this concept. Log of a power m is m into log a, x into log 10. So it's like this. Log a to the power of m is always equal to m into log a. Log 10 is, so it will be x into log 10. Log 10 is always 1, so you will get it as x directly. So log 10 power 8 is 8 directly. So it's based on that concept. However, if you don't know how to work with log, you can always type it into the calculator directly. Log 10 to the power of 8, you will get the answer as 80. Similarly, let us find out what is the SIL on the receiver side. Sound intensity level on the receiver side is 10 into log of, on the receiving side it is 10 to the power of minus 7 upon 10 to the power of minus 12. So this will be 10 into log of 10 to the power of minus 7 plus 12. So how much is this coming out to be? 10 into log 10 to the power of 5. So this is coming out to be 50 decibels. So on the source side it is 80 decibels here. In the other room it is coming out to be 50 decibel. How much is the loss due to the wall in the center? If there's no partition, everything would be 80. But due to this wall, there is a loss of 30 decibels, correct? The change in the sound or transmission loss, you can say, is 30 decibels. So that's how you calculate it. So this is based on only a single concept, that is 10 log I upon I reference. That's the only concept which we are applying in this particular question. Moving on. This again is a bit lengthy question and also a bit difficult. Let us try to look into this one as well. This is a 2 marks question from 2020 gate exam, if I'm not wrong. 2020, yeah, it is from 2020 paper. So in the plot shown below, S1 and S2 are two non-directional point sources having sound intensity level of 95 decibel and 60 decibel respectively at a distance of 1 meter from each point source. So in this question, there are two sources, S1 and S2. They're saying for S1, at 1 meter distance, it is having 95 decibels. See, if you're having any source, let us say there's a source S1. At 1 meter distance, they're saying that the sound intensity level is 95 decibels. Will it be 95 decibel at a far away distance also? Obviously, no, it will keep on changing. At 1 meter, we know it is 95 decibel for the first source. Similarly, for the second source S2, at same 1 meter distance, they are saying it is 60 decibels. It will keep on reducing as you increase the distance. They have given us the value at 1 meter distance. So that's the first thing. two non-directional point sources having a sound intensity level of 95 and 60 decibel at 1 meter distance from each point source that is given. Considering free field conditions, free field as in no one is stopping the sound in one particular direction, it is equally spreading in all the directions. So in free field conditions, the effective sound intensity level at the receiver is dash. They have given a plot. They're asking what is the sound intensity, how much will this receiver detect, or how much is the sound level at the receiver. So if you look into the diagram, the receiver is 9 meters away from S1, 9 meter away from S2 also. So how do you find it? There are two sounds here. You'll need to add both the sounds. How can you add both the sounds? You add the intensities. So we need to first find out intensity at the receiver due to the first source, then find out intensity at the receiver due to the second source and add them to get the total intensity. So let us do that. First, let us look into only one by one. The first source, let us focus first on the first source. So for source S1, at 1 meter distance, it is given as 95 decibels. For the same source, what will be the sound intensity at 9 meter distance, because the receiver is 9 meters away. So at 9 meter distance at this receiver, what is the intensity due to the first source? That we have to calculate. So we always will apply inverse square law. Vishant is absolutely correct. Whenever you have anything related to distance, you will get two cases, case 1, case 2, and you will apply inverse square law. So case 1 here is 1 meter, case 2 is 9 meter. Case 1's intensity is corresponding to 95 decibel. Can we not combine SIL? Then we cannot subtract 2, right? Umesh, no, it's not that way. If there are two rooms, if I say I'm detecting a sound of, say I first come into this room, ask you how much is the sound level. If I say 80 decibel, Umesh asked this question. If we cannot add, how am I subtracting 80 minus 50 and writing 30? Let me explain you. If you ask someone to stand in this room and ask him what is the sound level, he'll tell okay, it is 80 decibels. If you take that person to the other room and ask now how much is the decibel value, he'll tell 50 decibel. How much is it reducing by how much? What is the fall in the decibel value? That can be reduced. So the feeling of sound level from 80 to 50, that will be a fall of 30. That can be done. But combining is always done in terms of intensity levels. Uh, sorry, intensities, but not sound intensity level directly, right? So that is something which you can remember. You do not subtract the intensities and then find out the sound intensity level. So looking into this question, I was telling you at 9 meter distance, we should first find out the intensity. For that, to apply inverse square law, I need to know the intensity in the first case. Can anyone tell me 95 decibel is equivalent to which intensity? What will be the intensity in the first case? I told you the shortcut, any decibel value. If you're having 70 decibel, how can you convert that? 70 divided by 10, you will get 7. Subtract 12 from it, you will get minus 5. Write that in the power of 10. 10 to the power of minus 5 watt per square meter. 70 decibel will be 10 power minus 5 watt per. So divide by 10 and subtract 12. Write it in the power of 10. Okay. Apply the same logic and tell me what is 95 decibel. Anyone? 10 to the power of minus 2.5. Absolutely correct. It will be. So if you're getting 95 decibels, divided by 10, you will get 9.5. Subtract 12 from it, you will get 2 minus 2.5. Write that in the power of 10. If you're not convenient in applying, where did we get this shortcut? There is nothing, there's no random, say, steps which we are doing over here. It is based on simple logic. 95 is equal to 10 into log of I upon 10 to the power of minus 12. So this implies, if you simplify this, you will get the same thing. I is equal to 10 to the power of minus 2.5. That's what you will get. That's what we have done. So you cancelled out this 0, you'll get 9.5. Then write it in the power of 10 and subtract 12 in the power. That's what we are doing here. So 10 power minus 2.5 it is. If you wish, you can find out the exact value of 10 power minus 2.5 and also write it. This will be 10 to the power of minus 2.5 watt per square meter. Right? Now let us apply inverse square law for this to find out intensity due to source 1 at the receiver. So I1 into R1 square is equal to I2 into R2 square. This implies I in the first case is 10 to the power of minus 2.5 into R in the first case is 1 meter, 1 square is equal to intensity in the second case is I due to S1, IS1 into the distance in the second case is 9 meter, that is 9 square. This implies intensity due to source 1 will be 1 upon 81 into 10 to the power of minus 2.5. You can use your calculators to find the value of it. 1 upon 81 into minus 2.5. So can anyone tell me how much are you getting? You can type it in the calculator like this. 1 divided by 81. You will get some value. Multiply it with open bracket 10 raised to the power of open bracket minus 2.5 close bracket. So you type this into the value into the calculator. How much are you getting this as? So it's 1 divided by 81 multiplied by 10 raised to the power of minus 2.5. So it is 3.9 into 10 to the power of minus 5. We'll get this as, I'm getting this as 3.9040. 904 into 10 to the power of minus 5. This is the value of intensity to source 1. If you type it into the calculator, you will get 3.904 so on. In the end, you will find E minus 5. E minus 5 in the calculator is nothing but 10 to the power of minus 5. So don't miss out on that point. So that's the value of intensity due to source 1. Let us now try to find out intensity due to the second source also. Same step you need to do for the second source. If I apply the same thing, so let me erase this part. The values over here will change now for the second source. So if you're having second source at 1 meter distance, it is given as 60 decibels. Can anyone tell me 60 decibels is equivalent to which intensity? For the same source, intensity to second source at 9 meter distance, you need to calculate. Some of you have a doubt in Gale calculator. How do we apply minus 2.5 over 10? So I see there are some students who are having doubt with using the Gate calculator. Try to do it from the uh, official portal of Gate. But if you're still having a doubt, we will try to put out a video. We are trying to do that. We'll record a video and put out on a YouTube channel very quickly on how to use the Gate calculator. Right? Once you have a look at it, you will have clarity. But it's that pretty direct, simple. 10 raised to the power of open bracket and write minus 2.5. Directly you can type it. Can you please explain how to calculate 10 power minus 2.5 again? Shahana, sure. It's just you just open your scientific calculator. 10 raised to the power of open bracket minus 2.5 close bracket and press enter. Press is equal to. You'll get the answer for it. Right? This is what you need to type. 10 power minus 2.5. Just ensure that you use bracket properly so as to have no error in the final answer. Now that clear, Chana. So I will, many of you have given me the answer 10 power minus 6 watt per square meter. That will be the intensity. So we need to find out the intensity in the second source now. So let us do that. Applying the same concept again, I1 R1 square is equal to I2 R2 square. If I apply this, I will be getting I in the first case is 10 to the power of minus 6 into R in the first case is 1 square is equal to intensity in the second case is IS2, intensity to second source, into R2 square is 9 square. This implies intensity due to second source at the receiver will be 1 upon 81 into 10 to the power of minus 6. So this will basically be 1.23, I think, into how much is it? 1.234 is it? 1.23 into 10 to the power of minus 8. Is it 4 after 1 2? Is it 1.234? Acha, 1.234, correct. Mock test have the same calculator layout of the gate. Yes, Vishant. As far as I think, it is exactly same. But you can just be assured, 100% sure. You can once again practice on the gate website also. On the gate official website, they have a mock test of last year's paper itself. It's not a new mock test. Last year's paper, you can have a check of it. Uh, yes, you can drop a message if you have a doubt on test series and all. Drop a message on the official on our office number. They'll guide you. But you'll get access to the mock test very soon, probably tomorrow or so. To 1.234 into 10 power minus 8. That's the intensity at the receiver due to the second source. So we have the intensity at the receiver due to first and the second source both. You can find out the total intensity now. Total intensity at the receiver will be IS1 plus IS2. Intensity to first source plus intensity to second source. That will be 3.904 into 10 to the power of minus 5 plus 1.234 into 10 to the power of minus 8. So to write it in terms of decimals, it will be like this. It will be 0.1234 times 0, 3904. That's the value of The first term, 10 power minus 5 is take this decimal backwards by 5 places. So it will be 0.40309 3904. And this one, it will be 0.1234567 and then 1234. This is what you will get adding the intensity. Right. However, if you wish, you can take something common in it. Probably you can take 10 power minus 5 common and write it as 3.904 plus. You can take 10 power minus 5 common here. You can write also this as 10 power minus 5 into 3.904 plus. This will be three places backward. So it will be 0.001234. You can also write it like this. So it will be 3.905234, right? 905234. Where did 81 come from? Network issue. Ritu, it's like I1 into R1 square is equal to I2 into R2 square. This 81 is nothing but square of 9 meters. Distance in the second case is 9, right? Square of that is 81. So Piyush says there's some app where you can use the gate calculator on Play Store. I but will you to check it from the official website of Gate rather than depending on some third-party mobile applications. It is always better. Go to the official website of Gate. There's a mock test there. Open the calculator over there. That will be a full proof, right? Very easy to access also, rather than downloading some app and depending on it. So anyways, so add these and find out the sound intensity finally. Sound intensity finally. Let us say the sound intensity level at the receiver, that will be 10 into log of intensity at the receiver upon the reference intensity. And the intensity at the receiver we saw it is 3.90524 into 10 to the power of minus 5. This is what we were getting for intensity. Substitute this over there. How much are you getting the answer as? 10 into log of 3.905234 into 10 to the power minus 5 divided by 10 power minus 12. So this will be 10 into log of 10. The decimal will move forward by 7 places. So it will be 3905. This. This is what you will get. So find log of this number into 10. How much is it? 75. What is the qualifying mark required? Uh, it varies year to year. In GATE, the qualifying mark generally is from 35 to 40. That's the range generally. 75 point something is the answer will be in the range. 75 point something, 75 point. How much are you getting? 9. 75.9 decibel is correct. Anything, there will be a range given, so plus or minus something is perfectly fine. 91 is not correct, but 75 point something is the correct answer. Just check if you have done some error by book. So that's about this particular question. Moving on, let us now move on to the next concept. With that, let's now look into the concept of reverberation time and sound absorption coefficient and all. So this question from 2022 paper. So let me explain you something about reverberation time. So every surface has an absorption coefficient. So let us try to understand what is absorption coefficient. Absorption coefficient alpha of any surface is the fraction of incident sound that is not reflected by the surface. Alpha denotes fraction of incident sound which is not reflected by the surface. Fraction of incident sound that is not reflected by the surface is called as absorption coefficient. So can anyone tell me, this is a very frequently asked question. In last few years, two times question was asked. If you're having an open window, if sound is falling onto an open window, can you tell me how much percentage of this, if 100% sound is falling onto the window, open window, How much percentage will be reflected? How much percent of this sound will be reflected if it is an opening, if it is an open window? 0% will be reflected. What is happening to the sound because it is not reflected? It is basically it is going into the surface. It is transmitting through it, right? So reflected part is 0%. So what will be the not reflected part? The percentage of the sound not reflected will be 100%. This implies alpha of open window. What is alpha? Absorption coefficient of open window or open door, whatever it is. It will always be 1. Remember this concept always. Alpha for an open surface, open window is always 1. Why? Because alpha denotes the fraction of sound which is not reflected by the surface. And for an open window, not reflected part will be 100%. 100% is 1 in terms of decimal fractions. 90% will be written as 0.9. 80% will be written as 0.8. Right? It is this divided by 100. So 100% will be written as 1. So alpha will be 1 for an open surface. That is something which you have to remember for your examination. Other than alpha, you can also remember noise reduction coefficient of a surface. So in reverberation time calculation, the alpha we use, this is always measured at 1000 hertz frequency. So you can measure alpha by using some sound. Which sound will you use? You will always use 1000 hertz frequency sound while calculating reverberation time. That is a standard as per the Sebine's equation. Sebine's formula is a formula given for calculation of reverberation time, which we will look into in some time. It's based on a research done by Harvard University, and that standardizes alpha to be measured at 1000 hertz frequency in the calculation of reverberation time. What is noise reduction coefficient? It is an average absorption coefficient. It's an arithmetic average of the absorption coefficient measured at 4 different frequencies. It's an average of alpha measured at 250 hertz frequency, 500 hertz frequency, 1000 hertz frequency, and 2000 hertz frequency. For these 4 different frequencies, if you measure the alpha and find an average of it, how do you take an average? Add the values and divide by 4. That's called as noise reduction coefficient. Alpha for calculation of reverberation time is measured at 1000 hertz. If you take an average absorption coefficient at 4 different frequencies of 250, 500, 1000, 2000, that's referred to as noise reduction coefficient, and that is something which you have to remember. Let's look into this concept of noise reduction coefficient. Then I will tell you about the reverberation time concept. So if you look into this question, this is a 2 marks question asked in the architecture part in 2022 paper. So the acoustic absorption of a wall panel in each octave band is tabulated below. Noise reduction coefficient of it is being asked. I just told you what is noise reduction coefficient. Noise reduction coefficient is equal to alpha measured at 4 different frequencies: 250, 500, 1000, and 2000. Remaining data is unnecessary for us. These average of these 4 values is called as noise reduction. So 250 hertz, 500 hertz, 1000 hertz, and 2000. Add these 4 values, divide by 4. What is the noise reduction coefficient you're getting? 0.5 plus 0.5 plus 0.7 plus 0.8. Divide by 4. 0.625 is the correct answer for this question. That's the alpha which you will get for this particular question. The noise reduction coefficient which you will get for this particular question. Let us now look into the concept of reverberation time. Let us discuss the concept of reverberation time now. So reverberation time, as far as definition is considered, it's written as RT, generally written as RT60. So reverberation time, as the name suggests, it's the time. What time is reverberation? It is the time for which the sound stays in a space. So if I'm producing a sound in this room, that sound will stay in the room for some time. That time is called as reverberation time. If the sound stays in the room for a very short duration, now this becomes a very important aspect, particularly in design of large auditoriums, lecture halls, for large spaces where sound and clarity of sound is important, including movie theaters. It's very important to calculate reverberation time. So if reverberation time is very less, there will not be enough clarity for all the people in the room. Similarly, if the reverberation time is very high, that also will create a lot of confusion. It will basically create a overlapping effect in sound. So you might have seen generally in some small rooms, if you remove all the furniture in an empty house, the sound reverberates. That's not echo exactly. It's called as high reverberation. So reverberation time basically relates to that. In simple terms, the time for which sound stays in a space, or the time taken for a sound to fall 60 decibel below the original level, is called as reverberation time. So if there's a sound of 80 decibels, the time taken for that 80 decibel sound to fall to 20 decibel, that is, it is falling by 60 decibel. The time taken for a sound to fall from its level by 60 decibel, that is called as RT60. Now, why exactly 60? It is because most of the day-to-day sounds are close to 60 decibels, and you assume that if something falls by 60 decibel, it almost comes to a level which is not audible anymore, and that's the reason in Sabin's equation it has been standardized that reverberation time will be calculated for a fall of 60 decibel, and they have given, so in Sabin, so how do you calculate this? Using Sabin's equation. Let us try to understand Sabin's equation and practice one or two questions on it also, which is important from gate point of view. So as far as the formula for Sabin's equation is considered, reverberation time RT60 in seconds is given by 0.16 into volume upon total sound absorption of the room. 0.16 into V upon A. So in this formula, what is V? V is volume of the room. And remember, this volume has to be taken in cubic meter, not in non-SI units. You cannot take it in cubic foot or something. It has to be taken in cubic meter. This is a formula for SI units. And A here is referred to as total sound absorption. And this total sound absorption is measured in meter square Sabin, or you can simply call it as Sabin. So if someone asks you what is the measurement unit for sound absorption, the answer is Sabin. It is measured in Sabin. But sometimes you also write it as meter square Sabin. Even in gate examination, there are questions where they just mention Sabin. Sometimes they mention meter square Sabin also. So in general, the measurement unit for sound absorption is Sabin. The reason why we mention meter square is in calculation of sound absorption, you will use area also. And that area has to be taken in square meter. You cannot take it in square foot. So to mention and specify that area has to be taken in SI units, we mention sometimes as meter square Sabin. However, the measurement unit for sound absorption is Sabin only. So let us try to understand how to calculate it. So for this particular room, if I say, what is the reverberation time of this room? It is simply 0.16 into volume of the room. Volume is length into breadth into height. Volume of the room divided by the total sound absorption. Now, how do you calculate total sound absorption? Let us try to understand. Total sound absorption of a room is nothing but summation of the absorption coefficient and the surface area of all the room surfaces. Total sound, A here is total sound absorption. How do you calculate total sound absorption of any room? It is summation of sum of alpha into S for all room surfaces. So for all the room surfaces, you will add alpha into S. What is alpha? It is it should be meter Sabin. Pratik, no, it is square meter, meter square Sabin, not meter Sabin. Don't even in gate exam if you see. Let me see if I have some question on that. Probably yep, not in these questions, but yeah, it is meter square Sabin. Don't be misinformed. It is not meter Sabin. It is meter square Sabin. Square meter is the unit for area, right? Sum of alpha. Anyways, let us focus on how do you calculate it. It is sum of alpha into S for all room surfaces. So in this, what is alpha? Alpha here is absorption coefficient, which we already discussed. Alpha absorption coefficient measured at 1000 hertz frequency always. S is surface area of the surface. So for all the room surfaces, whatever surfaces you're having, for all those surfaces, you will find the surface area multiplied with S and add all those. So mathematically, it will come out to be like this: alpha 1 into S1, that is for first surface. So first you need to count how many surfaces you're having. Tile flooring is one surface, glass wall or glass partition is second surface, curtain or fabric is third surface, plastered wall is fourth surface, open window can be fifth surface. Open window also is a surface with alpha 1. So you'll need to count all the room surfaces, including the interior finishes. For every surface, find out the area and absorption coefficient and add them. Alpha of first surface into surface area of first surface plus alpha of second surface into surface area of second surface plus so on for all the n surfaces of the room, alpha of the nth surface multiplied by the surface area of the nth surface. So alpha into S for all the room surfaces. That addition, that sum is called as total sound absorption. It can also be written like this: sigma. Sigma is summation. So summation of alpha I Si, where I is equal to 1 to n. From 1 till n, alpha into S, summation of it. That's called as total sound absorption. So reverberation time will be 0.16 into volume of the room upon total sound absorption of the room. Because you're using this surface, why do you write meter square sub in sometimes? Because you're using this surface area over here, this surface area. This area has to be taken in square meter. To specify that it has to be taken in square meter, not in square foot or square centimeter, square inch. That is the reason why you write meter square sub in sometimes uh, in the measurement unit for total sound absorption. So that's about the calculation of it. Let us practice few questions to understand how to solve these questions in the examination. Let's practice a few questions now. Uh, Probably let us solve one question at least. So there are three questions over here. Let us solve one question in the class. The remaining ones you can do it yourself. So let us solve this question over here. Uh, the remaining, I told you I'll share you this sheet. You can practice the remaining questions yourself. What is this factor 0.16? Nishita, this formula actually, it is based on some research. It's not a derived formula. So as I told you, it's called a Seventh equation. It's based on a research done by Harvard University. So basically, they have collected data on various auditoriums, various rooms, and have used some statistical software and derived this formula. They have observed that, so it's not consistent with units. You see, volume is in cubic meter. This is in 7. You're getting an answer in seconds. So there's no meaning as it's based on empirical research and study. That's how you get this formula. So it doesn't have any name for that factor. Uh, I was telling you, we'll solve one question. Remaining questions you can solve it yourself. Let us look into this particular question. This is a 2 marks question from 2022 paper or 2021. It could be 2021 or 2022. It is a 2 marks question. Let us see. Rectangular hall having dimensions of 8 into 14 into 4 meter has 4 windows and 2 doors. The coefficient of absorption are given below. Consider all windows. Now this is key here. They are saying that all windows are open and doors are closed. The reverberation time in that case will be dash. That's what they're asking. If everything is closed, so you can see over here coefficient of absorption for door and window. If it is closed, it is 0.4. But there are some open windows also over here. Windows are open. So there are three types of surfaces in all. Coefficient of absorption for wall, floor, and ceiling, that is 0.2. Let us say this is alpha 1. For the second surface, alpha 2, that is 0.4. Where is alpha 0.4? For the closed door. So let me cut off this window part in this question because windows are not closed. If windows were closed, it will be 0.4. But windows are open here. What will be the alpha for open windows, anyone? The third surface is open windows. For open windows, what will be the alpha? Open windows will have an alpha of 1, 1.0. So I have written the alpha for all the room surfaces. Similarly, I need to know the surface area of all the three surfaces. You need to know the surface area of the first surface, second surface, and third surface. Let us write from the bottom, it will be easy. What is the total surface area of the open windows? Anyone? There are 4 windows and each window is of this size. So what is the surface area of the windows? Each window is 1.5 square meter. There are 4 such windows. So it will be 6 square meter. Surface area of the windows is 6 square meter. What is the surface area of the doors now? There are 2 doors. Each door is 1 meter into 2 meter. So that will be 4 square meter because there are 2 doors. Each door is 2 square meter. The remaining part, wall plus floor plus ceiling. Wall plus floor plus ceiling, that will be total surface area. Total surface area of a cuboid is 2 into LH plus BH plus LB. That's the total surface area. Wall plus floor plus ceiling. That will be total surface area minus 10 square meter. Why? 10 square meter is fenestration, door and window. Can anyone calculate and tell me what is this wall plus floor plus ceiling coming out to be? Total surface area, 8B is 14 and H is 4 meter. You can simplify total surface area first and subtract 10 from it. Total surface area you're getting 400. Okay, this should come out to be 400 square meter. So wall plus floor plus ceiling will be 400 minus 10, 390 square meter. So this will be 390. So you have alpha and S for all the room surfaces. How did I get total surface area 400? Anyone? Total surface area will be 2 into L into H, that is 8 into 14 or 8 into 3. It's like this. 8 into 3 is 8 into 4. 8 4 is 32 plus 14 into 4 is 56 plus 8 into 14 is 112. So that will be 2 into 200, that will give you 400, right? So that's how I got this as 400. Applying the surface area of a cuboid, that's it. So let us try to find out the total sound absorption. Now there are three surfaces, so alpha 1 into S1 plus alpha 2 into S2 plus alpha 3 into S3. How much is this? Alpha 1 into S1 is 0.2 into 390 plus alpha 2 into S2 is 0.4 into 4. Alpha 3 into S3 is 1.0 into 6. How much is this coming out to be? Total sound absorption, anyone? 85.6. Okay, thank you. Meter square 7. That's the value for the total sound absorption of the room. Now, from this, you can find out reverberation time is equal to 0.16 into volume of the room is L into B into H. Can anyone tell me what is the volume? 8 into 14 into 4. 448. Volume is 448 cubic meter divided by total sound absorption is 85.6 meter square 7. Simplify this and tell me what is the answer you are getting. 0.16 into 448 divided by 85.6. 0.83, 0.84. Okay, that's the answer. 0.83 or 0.84 seconds. That's the correct answer for this question. So it's based on this concept. What are they testing over here? Other than the calculation of reverberation time, they are basically checking your knowledge if you know that the open windows will have a total sound absorption or the absorption coefficient of 1. That's what they are basically testing over here. I will share you this. Will it be in the range, Anushka? Absolutely, yes. There will be a range. Plus or minus few digits is fine. So you can solve these remaining questions. I'll share you this PDF. These questions also based on the same approach. You can try to do it yourself. There's this 1 mark question also in 2018 question. So you see here the sound absorption they're asking in 7. They're not mentioning meter square 7 as such, right? You can also try to. Actually, this is a very simple question. Can anyone tell me the answer for this? Room is 3 into 3 into 3. The reverberation time is directly given as 0.8. They're asking us what is the total absorption of the room. A is being asked. Okay, someone has a question. We enter 4 decimals. If they mention only 2, will the answer be considered wrong? Umesh, no. They'll not give you a wrong answer. You can type 4 decimals also in the exam. But advisable to just write 2 decimals. They're asking for 2 decimals. Round off to 2 decimal places and give the answer. That's better always. This is 0.16 into volume upon area, the total sound absorption. So this implies volume upon total sound absorption is equal to 0.8 upon 0.16. This implies total sound absorption is equal to volume divided by 0.8 into 0.16. This is how you will get this is what the answer will be. Volume into 0.16 upon 0.8. Volume is 3 into 3 into 3. That will be 27 into 0.16 upon 0.8. How much is the answer coming out to be? 5.4 is the correct answer. 5.4 meter square 7 or 7. That's the answer for this question. So that 1 mark question in 2018 actually. So let us now move on to some theoretical questions of acoustics before we move on to the lighting part. That's the last part for today's session. So the first question, the measurement unit for Sound absorption of a room in 2017, it was asked for 1 mark. 7 phone decibel hertz. Obviously, 7 is the measurement unit. A is the answer for this question. Phone is the, if you, for your information, let me tell you these other units. Phone is the measurement unit for loudness. Decibel is a measurement unit for sound level. Sound level and loudness are similar but not same terms. I would recommend you can read about what is phone and what is loudness. How is it different from sound level? You can have a revision on that in your self-study once. If you want to, if you do not know the difference yet. I'm sure those students from the class already know that the loudness and sound level are different aspects, different terms. There's a slight difference between them. Not very important, but you can remember this definition. Is the phone measured at 1000 hertz? Yes, Rohit. Actually, phone is basically the loudness or the value which creates the same sensation of 1000 hertz frequency sound. You're correct. It's based on equal loudness contours. So hertz is a measurement unit for frequency, sound frequency. Those are the incorrect options and the measurement units of it. So let us now look into this math. The following question from 2019. This was asked for 2 marks. Decibels is a measurement unit for sound level. Sound level can be sound intensity level, sound power level, or sound pressure level. There are three types of sound level. So sound pressure level is the answer from these points. So decibel, it will be 5. Phon is the measurement unit for loudness. Watt per square meter, you know, is already measurement unit for sound intensity. Sabine is a measurement unit for absorption of sound. 5412 is the answer. So D is the correct answer for this particular question. Next, this one, I'm sure you all can answer. This is a 1 mark question from 2014 paper. Actually, I think it was a 2 mark question. I'm not 100% sure, but yeah, it is a 2014 question. The arithmetic average value of sound absorption coefficient for a specific material and a particular mounting condition for 4 frequencies is called. What is the average absorption coefficient called as? Transmission coefficient, noise reduction coefficient, absorption coefficient, and reflection coefficient. Obviously, noise reduction coefficient is the answer for this question. B is the correct answer. These are some theoretical questions related to the concepts which we have covered till now. Let us, with that note, move on to the lighting part of the lecture, the last part. Let us revise about the lighting and illumination part as far as lighting topic is considered. You generally get questions related to photometric properties or calculating number of lamps required. We will learn both the concepts one by one. Let us revise some basic photometric properties. What are photometric properties? Photo is light, metric is measurement. Photometric properties are those properties which you use to measure light. So if I ask you how much is the light in this room, you will give some number, measure it in some particular value. So measurement of light level in a room is measured in lux. It is called as illumination. Similarly, there's something called as lumen, there's something called as candela. So let us try to understand what are these various terms. What is luminous flux, luminous intensity, luminous illumination. So let us try to look into these terms. These are all called as photometric properties. The first one is called as luminous flux. It is denoted by F. A brief definition: luminous flux is nothing but it is the rate of flow of light energy. So it's basically rate of flow of light energy per unit area per unit time. It's just like other power. Also, power is measured in watts, joule per second. So basically, so luminous flux not per unit area but per unit time. Rate of flow of light energy per unit time is called as flux. Luminous flux is nothing but it is light, or it's a measure of light energy. Flux is nothing but measure of light energy traveling per unit time or emitted per unit time. That's called as flux. This is measured in units of lumen. So it's just like what? So basically, what is power? Power is nothing but energy emitted per unit time. It is measured in joule per second. Any power. If I ask you what is sound power is nothing but how many joules of sound is emitted per unit time. Joules per second. Heat also, rate of flow of heat also is measured in watts. Joule per second is nothing but Watt, right? Even in light, in the climatology part, in the beginning, we saw watt per square meter as the intensity of solar radiation. So that also is measurement of quantity of solar energy per unit time, joule per second, which is measured in watts. Even light also is a type of energy. You can also measure it in watts and joule per second. But there's a measurement unit specifically for light energy also. So there's a conversion factor. How can you convert lumen to watts? For that, we use luminous efficacy. So I'll tell you about it in a while. But for now, remember, luminous flux is similar to watts. It's rate of flow of energy, basically, energy per unit time, which is measured in lumen. So it is similar to watt. It is related to watt. The conversion factor from lumen to watts, I will tell you about that later, right? That was the first point. Second important photometric property is luminous intensity. Luminous intensity I is defined as the rate of emission of flux or light energy, flux emitted per unit solid angle. That's called as luminous intensity. It's flux emitted per unit solid angle from a source. That's called as luminous intensity. So it's defined as flux emitted per unit solid angle. So by definition, intensity is flux emitted per unit solid angle is generally denoted by omega. So what is the meaning of solid angle? Let me also briefly tell you in this revision part. I'm not going into the details of it. In the lecture we discussed that in detail, what is solid angle, how to measure it and all. But in simple terms, solid angle is a three-dimensional angle. So if you're having a light source from one steradian, so solid angle is measured in steradian. From one steradian solid angle, how much light energy is coming out or how much flux is passing out from one steradian, from one unit solid angle. That's called as luminous intensity. Energy emitted per unit solid angle. Solid angle is a three-dimensional angle measured in steradian. So what will be the measurement unit here? It will be flux is measured in lumen. Denominator, solid angle is measured in steradian. SR is steradian. So it is measured in lumen per steradian. So this question also was asked once. Candela is also called as lumen per steradian is called as candela. This is called as candela. So the measurement unit for luminous intensity is candela, which by definition is nothing but lumen per steradian. Steradian is the measurement unit for solid angle, and intensity is flux emitted per unit solid angle. That's about the second photometric property. So if you look into the difference, luminous flux is measure of light energy in general. So I can ask you how much flux of light is coming out from the board. Light, the board also is a type of source. How much flux is coming out from the source? How much flux is coming out from this light? How much flux is coming out from that light? So that is flux. Luminous intensity also is measured for a light source. So I can also ask you how much flux is coming onto this floor, light energy received on the floor. But I can ask you what is intensity of a light. So what is the intensity of this bulb? Intensity is measured for a light source. It is flux emitted per unit solid angle from a given light source. That's the second photometric property. Third photometric property, third photometric property is illuminance, an important one. Illuminance, illuminance of a surface. That is denoted by E. So illuminance tells you how brightly a surface is illuminated. If there's this wall, if I switch off all the lights, it will become dark. Or if I switch on all the lights, this room will be brightly illuminated. So the level of illumination of a surface is nothing but how much light energy is received on a surface. So what is illumination or illuminance or illumination of a surface? It's also called as illuminance, or it's also called as illumination. What is illuminance or illumination of a surface? It is nothing but the quantity of light energy received per unit area of a surface. Quantity of light energy received per unit area of a surface is called as illuminance. Illuminance is nothing but light energy is nothing but flux received per unit area. F upon A is called as illuminance. Now I'm not going into the detailed derivation here. I'm just explaining you the definitions quickly because it's a revision session. So Illuminance is nothing but flux received per unit area. So based on this, this is an important formula. Numericals are asked on this formula also. So flux is measured in lumen. The denominator is measured in square meter. So what will be the measurement unit for E? Measurement unit for E will be lumen per square meter, and lumen per square meter is called as lux. So the measurement unit for illuminance is lux. So first point we saw luminous flux measured in lumen. Second is luminous intensity measured in candela, which is nothing but lumen per steradian. Third is how much energy is received on a surface. If you're having 1 square meter surface, how much of light energy is received, how brightly it is illuminated. That's called as illuminance, measured in lux, which is lumen per square meter. That's the third point. Now, within this third point, or in extension to this third point, you actually have to remember the other formulae. What are the alternative formulae to measure illuminance? Light, that is point number 4. Illuminance is also calculated as I upon r square into cos theta. This is called as Lambert's cosine law. So I upon r square into cos theta. What is the meaning of this? Illuminance at a point. This is illuminance at a surface. This is used when you want to find out illuminance at a particular point. So illuminance at a particular point. That is kind of, if I ask you not for this room, but exactly at this point, what is illuminance? For that, we generally use I upon r square into cos theta. What is I here? I is intensity of light or intensity of the light source. That is I. R is distance from the source to the point under consideration. Theta is called as angle of incidence. Angle of incidence is defined as angle between the incident ray and the normal at the point of incidence. This is a surface. Let us say this is a point of incidence. If this is an incident light ray, angle of incidence is angle between the incident light ray and the normal drawn at the point of incidence. That's called as angle of incidence. Always, angle of incidence is angle between the incident light ray and the normal drawn at the point of incidence. That's what angle of incidence is. So this is called as Lambert's cosine law. The fourth point, E is equal to I upon r square into cos theta, where I is intensity of the source, r is distance from the source to the point, theta is angle of incidence. Right. So these 4 points are the basic ones with respect to the basic part of lighting, that is the basic photometric properties. Let us look into some questions from this part. So flux emitted, the first question. This is a 2 marks question from 2013 GATE examination. Let us look into this point. Flux emitted from a 1 candela light source in all directions in lumen will be dashed. They're asking us the flux. Intensity is given as 1 candela. What is the relation? Intensity is nothing but flux per unit solid angle. So this implies flux is equal to intensity into total solid angle. Remember, for a spherical propagation, so solid angle is basically measured as a 3D angle. So the total solid angle is always 4 pi steradians. Just like the total angle in a circle is, total angle in circle, how much is it? 360 degrees it is. Similarly, total solid angle of a sphere, total solid angle at a point, at the center of a sphere, you can say. That is 4 pi. How do you get that 4 pi? Because surface area of a sphere is 4 pi, 4 pi r square, right? That's how you get that 4 pi. So remember, that is something you have to remember. So using that, total flux will be intensity multiplied by 4 pi, because they're talking about the total flux emitted in all directions. So when light is emitted in all directions, that will basically be 4 pi steradian. So this will be, I is given as 1 candela into 4 pi steradians. So candela is nothing but lumen per steradian, right? This is nothing but 1 lumen per steradian. So you'll get your answer in lumen. That will be 4 pi lumen. You want a numerical answer? Pi value is 3.14. Multiply it with 4, you will get 12.56 lumen. So that's the correct answer. I think most of you have given the answer correctly. So this is based on the concept that the total solid angle at a point at the center of a sphere is always taken as 4 pi steradian. Why is it 4 pi? We have discussed that in our lecture, if you remember. So the next one. Uh, so this one again is based on Lambert cosine law. Let us look into this question, practice this one. A lamp source of intensity of 3200 candela. So candela is nothing but a measurement unit for intensity. So even though they are not mentioning intensity, you have to remember candela is the measurement unit for intensity. The lamp source of 3200 candela is mounted on a wall at a height of 2 meters from the work plane. Draw a diagram only, then you can answer this question. There's a work plane, and on a wall there is a light source fixed on the wall at a height of 2 meters from the work plane. This is the work plane level. At 2 meters from the work plane, there is a light fixed on the wall. This is a wall surface. It subtends an angle of incidence of 60 degrees with the center of the work plane. So it is having an angle of 60 degrees with the center of the work plane. This angle of incidence is always angle between the incident light ray and the normal drawn at the point of incidence. You will not take it with the base. You will not take it with the horizontal. Always it is distance. It is angle made with the vertical or normal at the point. That's the definition of angle of incidence. Illumination at the center. They're asking what is the illumination at a point. Illuminance, whenever they're asking at a particular point, can we make rough diagrams during an exam? Yes, Prankur, you have to. Not you. It's the question is ki, should you do it or not? You have to actually. Otherwise, you will have a mistake. They'll give you that booklet and you have to draw the diagram and solve. Otherwise, it will be very difficult to answer the question, particularly such ones, such questions. So, E at a point, you always use E is equal to I upon R square into cos theta. I is directly given. Theta also is directly given as 60 degrees. R you have to calculate. R is not 2 meters. R is the distance from the point. So what is given? This height is given as 2 meters. But R is this angular distance, right? So this hypotenuse of this triangle. This is R. How do you calculate that R? You need to draw this right angle triangle. This is R. This is given as 2 meters. This is 90 degrees. If this out external angle is 60, can anyone tell me what will the remaining angle here be? 60 degrees is the angle of incidence. The internal angle, this will be 30 degrees. Now in this right angle triangle, you can apply sine 30. Sine is the relation between the opposite and the hypotenuse. So in this right angle triangle, if I apply sine 30 degrees, I will get sine 30 is equal to opposite side upon the hypotenuse, 2 upon r. And what is the value of sine 30? Sine 30 is 1 by 2 is equal to 2 by r. So this implies that distance of hypotenuse r will be 4 meters. Now I got the value of r, I have the value of theta, I have the value of intensity. So if you look into this question, the value of theta and I are directly given to you in the question. Your work is only to calculate the value of r. And how do you calculate the value of r? Using trigonometry. By drawing the right angle triangle, by drawing the diagram properly. Substitute the values over here. How much are you getting this as? I is basically 3200 upon r is 4, so 4 square into cos of theta is 60 degrees. So this will be 3200 divided by 16 into cos 60 is 1 by 2. So 3200 divided by 32, you will get your answer as 100 lux. So at the center of the work plane, the answer is 100 lux. How did I get that 100? By applying inverse square law. E is equal to I upon r square into cos theta. I hope this part is clear. You need to draw the diagram carefully. That's where so many people do this mistake. They directly take r as 2 and solve it. That's not how it is. So as I told you, in the GATE exam, they'll always not give you direct formula substitution questions. You will need to apply some logic and then answer the question accordingly, right? So that's the concept of this Lambert cosine law based question. This is a bit lengthy, but okay, let us try to solve this question as well. But before that, let us look into this one. This is a simpler question. A painting in a living room needs to be lighted at 250 lux. If the light is incident normally on the painting from a distance of 6 meters, the intensity is dash. So there's a painting and light is incident normally. Normally, matlab मतलब, perpendicularly. So can anyone tell me what is the angle of incidence in this case? the light is incident normally. What is the angle between the incident light ray and the normal at the point? Is it 0 or 90? It will always be 0 degrees, not 90 degrees. This will be 0 degree. Why? Because angle of incidence is angle between the incident light ray and the normal at the point. Normal at the point also is in the same direction. The angle will be 0 degrees. So theta is 0 degrees in this question. E is given. They want an illuminance of 250 lux. Intensity is being asked, and the distance r is given as 6 meters. So direct formula substitution question. Just that you need to carefully write it as theta is equal to 0 degrees. So E is equal to I upon R square into cos theta. E is 250 is equal to I, you don't know, I upon R square is 6 square into cos theta is cos 0 degrees. So 250 is equal to I upon 6 square is 36. Can anyone tell me what is the value of cos 0? In the beginning also in solar architecture a while ago we solved in climatology. Similar question, cos 0 was 1. So this implies intensity is equal to 36 into 250. That will be 9,000 candela. That's the intensity. So D is the correct answer for this question. So it's based on this concept of Lambert's cosine law again. So they just gave you this. So remember, whenever the light is incident normally, theta will be 0 degrees, and you can directly eliminate this cos theta because cos theta will be 1 in that case, right? So in this incident, in the case of incident normally, E is equal to I upon R square can be applied directly without cos theta. So that's about it. So this one, let me explain you the concept of this question. You can try to solve it yourself because I want to discuss one last concept after this, that is number of lamps in a room. So let me briefly explain you this particular question. You can completely solve it yourself later. I'll explain you the concept of it. A circular cricket field of 180-meter diameter is illuminated by 4 floodlight towers. The floodlight towers are equally spaced along the perimeter of the field. The height of the floodlight tower is 48 meters. So there's a cricket field, circular cricket field, with 4 floodlight towers at 4 places, which are equally spaced. And the diameter of the cricket field is given. All the floodlight towers, the height of them is given as 48 meters. What is given using inverse square law. Inverse square law is nothing but E is the Lambert cosine law itself. This is called as inverse square law too. The fourth point, because it is inversely proportional to square of distance. So this can also be called as inverse square law. So they're saying using inverse square law, illumination level at the center of the cricket field, at this center point, illuminance is given as 750 lux. Each tower has 50 lamps. The rating of each lamp is 700 watt. Efficacy of each lamp is dash. So efficacy is nothing but that relation between a lumen and watt. How many lumens is emitted per consumption of unit power, unit watt. That's called as efficacy. Lumens of light emitted per watt. The conversion factor I was talking about, lumen to watt, that's called as efficacy. This is not a standard conversion factor. It depends on the source. For incandescent bulbs, it will be different. For LED bulbs, it will be LED bulbs have a higher efficacy. Uh, in inefficient, like incandescent bulb have a very low efficacy. So it depends on the type of functioning of the light fixture actually. So in this particular question, E at the center is given as 750 lux, and each floodlight tower they're telling that they have 750 lamps. The first focus here, if you want to find out the efficacy, you want flux per unit power. So what is efficacy? It is ratio between flux, luminous flux, and power of the source, the wattage. That's called as efficacy. So power is directly given in the question. 700 watts is the power. Our focus is to find out the flux now, right? That's how you can get the answer. So to get the value of flux, you should first know the intensity. You apply inverse square law, you will find out the intensity. So let us look into this question. E at the center is 750 lux, but this is due to 4 floodlight towers. This is due to 4 floodlight towers. So what will be the illuminance due to one tower? Illuminance due to one tower will be 750 divided by 4. Can anyone tell me how much is this coming out to be? 180 something? 187.5. That's the illuminance due to one floodlight tower. Now, E, you can apply inverse square law. Take any one floodlight tower. This is the right angle triangle. This is the incident light ray. This is R. Height is 48 meter. What is the base? What is the radius of the cricket field? The diameter is given as 180. So this will be 90 meter, right? So for this floodlight tower, this is given as 90. This is 48. Can anyone tell me, apply Pythagoras theorem and tell me what is the hypotenuse? It will be square root of a square plus b square. Square root of 90 square plus 48 square. How much is that coming out to be? 102. Applying Pythagoras theorem, you can get R is equal to 102. We need to find out the intensity of it. Cos theta also, this is angle theta. If this is angle theta, this also will be angle theta. By looking into this triangle, you can tell what is cos theta. Ratio between adjacent side and hypotenuse. It will be 48 upon 102. You need not find the exact value of theta. You can right away look into the triangle and write what is cos of this angle, adjacent side upon hypotenuse. So you look at it from this side, base upon hypotenuse, right? 48 upon 102. That's the value of cos theta. Now apply inverse square law. E is equal to I upon R square into cos theta. This implies due to one floodlight tower, it is 187.5 is equal to I upon R is 102. 102 square into cos theta is 48 upon 102. Now this you have to simplify. And once you simplify this, you will get the intensity of the floodlight tower. I of one floodlight tower. That you will get from this intensity of one floodlight tower. You will get it as 187.5 into 102 cubed. This is square into 102. Divide by 48. This will give you the value of intensity of the floodlight tower. If you want intensity of one lamp, each floodlight tower they are saying is having 50 lamps. It's given over here 50 lamps. So divide this by 50, you will get the intensity of one lamp. Multiply that with 4 pi intensity multiplied by the solid angle, the total solid angle. That will give you the flux, right? So from that flux, you can find out efficacy. So the remaining steps you can try to do it yourself. I gave you the initial approach to it. Intensity of one floodlight tower we have calculated. Divide this by 50, you will get intensity of one lamp. Once you get the intensity of one lamp, you need to multiply it with 4 pi like this. We solve this question over here. Intensity multiplied by 4 pi will give you the flux. From that, you will get the value of flux. Once you get the value of flux, flux divide by power. Power is 700 watts. Whatever flux you're getting, divide that by 700, you will get the answer for the efficacy. You can try to solve it that way. In the official answer key, two answer key ranges were given. In one, they have directly considered I is equal to flux. In one answer key, they have considered I is equal to, or flux is equal to I into 4 pi. So in one, they have randomly assumed the solid angle to be 1 steradian, right? So this is the more appropriate approach. You can do it this way, or you can also take 1 steradian solid angle also and solve it accordingly. Either way, actually the solid angle ideally should be given to you in the question, but because they did not give, they gave marks to even those people who considered solid angle as 1 steradian. They gave marks to those people who have also considered it as 4 pi. So accordingly, you can solve the question further, right? The last concept before I end this particular topic of lighting, last concept we'll be looking into is to understand about the calculation of number of lamps required in a room. Remember, number of lamps required in a room. How many lamps you require in a room? There's a formula for that. That is illuminance required in the room multiplied by the surface area of the room divided by flux output of 3 lamp into utilization factor and maintenance factor. Now, I'm not deriving this. In the class we had in a full length lecture, if you remember, if you have attended the classes, we have derived and looked into this formula. But for revision part, let me just right away tell you, recall the formula for you. How do you calculate the number of lamps required in a room? It is illuminance level. E in the room, E is illuminance required in the room. What is the illumination level required in the room, right? This is also called as light level. Light level required in the room. This is measured in lux multiplied by the area. This is called as the surface area in square meter divided by F here is flux output of each lamp of one lamp. This is in lumen. Flux output of one lamp in lumen multiplied by the utilization and maintenance factor. In this, there are two factors we use. UF stands for utilization factor. MF stands for maintenance factor. We multiply the flux with these factors to get the effective flux output. So what are these factors? Why do you multiply? We had studied that in a full length lecture, if you remember. So number of lamps required in a room is illuminance level of the room required in the room multiplied by area of the room divided by the flux output of each lamp, one lamp multiplied by the utilization and maintenance factor in the denominator. So there have been questions in the past on this formula also directly asked. It's also an important concept in lighting. So let us look into this question. So this is a 2 marks question from 2015 GATE exam. A classroom measuring 10 into 8 into 2.7 requires an illumination level of 500 lux on the desk level. So can anyone, so this is the room, 10 into 8 into 2.7. Can anyone tell me what will be the area at the desk level? Desk level is nothing but area, it will be similar to the area of floor only, right? So the illuminance level required is given as 500 lux. Where do you want this level of lux? On the desk level. So what is the area of the desk level? It will be 8 into 10, 80 square meter. So that's the lux. So you need to see where do you want that lux on the desk level. Area on desk level is this much. Uh, they are using 40-watt fluorescent lamp with the rated output of flux output of each lamp is given as 5000 lumen. And utilization factor is given as 0.5, maintenance factor is given as 0.8. If the factors are not given, you will directly take them to be 1. If the factors are given, you will consider the value given. They're asking us the number of lamps required. I told you, number of lamps is illuminance multiplied by area divided by flux into utilization factor into maintenance factor. So how much is this? Illuminance is 500 lux, area is 80 square meter, flux output of each lamp is 5000 into utilization factor is 0.5, maintenance factor is 0.8. How much is the answer you're getting? You can simplify this. 500 into 80 divided by 5000 into 0.5 into 0.8. That will be 20 lamps. Based on the exact same concept, there's this one more question. You can try to solve it yourself. We'll just solve the first part of it because it has something to do with efficacy. So what is given in the question? A room of size 100 square meters is illuminated by 10 lamps of 40 watt each. 40 watt is the power. And the efficacy is given. Efficacy is nothing but the ratio of flux and power. That is given as 50 lumen per watt. They're asking us what is the flux emitted by the lamps in lumens. Can anyone tell me what will be the flux emitted by one lamp? From this, flux is nothing but efficacy into power. Efficacy of the lamp multiplied by the power of the lamp. How much is this coming out to be? What is the flux of one lamp? 2000 you're getting. Efficacy is 50 lumen per watt. Multiply it with power. Power is 40 watts. So you will get your answer as 2000 lumen. 2000 lumen is the flux of one lamp. What will be the total flux emitted by the lamps? They are using the word S, letter S here. All the lamps. How many lamps are you having? There are 10 lamps. So what will be the answer for this question for all the 10 lamps? D is the correct answer because there are 10 lamps. Total flux will be 10 into 2000. 20,000. Second part, they're asking, I think, illuminance. So utilization factor is given, maintenance factor is not given, so you'll take it as 1. You can solve this question yourself by using this. Number of lamps is equal to E into A upon F into UF into MF is not given, so you'll take it as 1. So they're asking the value of E. N is known 10, A is known 100, flux of each lamp is known 2000. You'll take 2000, you'll not take 20,000 here because F here is, you remember, what is F in this? Flux output of each lamp, of one lamp. For one lamp, you'll need to take 2000 over here, right? You can simplify it and you'll get the value of E. I see some of you are getting the answer already as 100. I think that's correct. You can solve it yourself in your self-practice once. The last question for today's session, the one with the measurement units here. So starting with the first one, can you tell me what is the measurement unit for illuminance? What is the measurement unit for illuminance? We discussed illuminance. E is measured in lux. So P, the answer will be lux, but you don't have lux in the options directly. Lux is nothing but lumen per square meter, or lumen is it? Lux is nothing but lumen per square meter. Lumen per square meter is 3. For P, it will be 3, right? Next, luminous intensity. For Q, luminous intensity is measured in flux per unit solid angle. It is lumen per steradian. That is nothing but candela. So lumen per steradian is not given, but candela is given. So it will be 1. Luminance, we did not discuss about luminance, so you can do this in your self-study once. Luminance is measured in candela per square meter. And luminous efficacy, we discussed lumen per watt. So 3124. So 3124 is option D. D is the correct answer for this question. So that's a quick revision on the lighting part. I hope this revision session was helpful and useful for you. Recording of this session will be made available to you on the app. The questions which we have solved, the questions, I will share it on the app as well for your self-reference. You can cross-check that. If you have any further doubts, for additional practice, you can solve the mock test also. So that is all for today. I hope that is all. Any doubts you have, you can ask me. It would be really helpful if the recordings today will be uploaded and visible in the app by today. Will help daily revisions. Sanjana, we will try, but I think it will take some time because Zoom recording, it takes some time for us to get the output and get it uploaded. But we'll try to do it at the earliest. Yep. Thank you all for attending the session. We'll meet you in the next class. By app for iOS, you'll need to download Classes app, Ritu, I think. Just connect with the office number and they'll help you out. And we access the test after these 7 days. Shruti, yes, you will have access to all the recorded lectures, test series, everything till the GATE exam. I can't see it on my batch info. Simran, you can just get in touch with the office number once. They will help you out. If it is not yet visible, probably it will be made available to you very soon. Just talk to them once, right? Thank you all for attending the session. Bye and have a nice day. We'll meet you soon in the next class. Ritu, you can call them once on the number 9560252666. That's the contact number. You can call them on this number. That's the contact number 9560252666. I'll help you out.